Broadcast is now starting. All attendees are in listen-only mode.
Okay, good. And there it is, Margaret, co-sponsored by BCS Specialist Group on Quality. Okay.
That's great. Thank you.
Thank you.
And every time that I've heard your lectures, even if it's a topic I've heard before, I learn more each time.
People say that.
Yeah. Pick up. So it's great,
When I
fantastic.
do the secret trick, I remember everything I've ever said while you were present, and I try to say something different next time.
Ah, well worth listening to.
Oh, how is the video of me? I can't actually see it.
It's good. Yeah,
the lighting good enough?
You're properly centered. You're lit well enough. It's wonderful.
Okay.
And we can hear you, which is great.
Okay, yeah, I was wondering whether I should get myself a proper microphone. I'm actually using the Mac Pro microphone and camera. But it seemed to work last time. Nobody made any remarks, so I thought I'd just continue.
I'll make some introductions in about 3 minutes' time. Leave the field clear for you.
You can hear us now, though. Someone started a broadcast. You did it.
I did.
Okay. They can hear us now.
Yes.
I was thinking in the past, so many people came up to London to hear your presentations, Tom, but at least this one actually, you can sit back with a cup of tea at the same time.
Yeah.
Rather than wait for the tea breaks.
And people can come from anywhere in the world, actually.
Absolutely.
But a 3-hour course is not a 2 or 3 day course by any means. And this course was planned as a interactive workshop where I don't lecture so much. But the moment we get down to half a day and people spread about, it's very difficult to do a workshop course. So this is the best.
Would it be possible to ask anybody that's from outside the UK if they could just send a message on chat just to say which country they're listening in from?
Yeah, that'd be fun. Okay, so as Margaret said, if anybody wants to sort of in the chat tell us where you're from, even if it is the UK, be fun to know.
Yeah.
After that,
we've got somebody from Zurich in Switzerland, someone from Scotland.
Hey, Switzerland and Scotland. Okay, welcome.
Great. The webinar 2 weeks ago, we had 38, one from Saudi Arabia, one from Sri Lanka, and one from Mauritius.
Okay, now which webinar are you speaking about? Mine or somebody else's? Or
no, it was one that we had about how to get to FBCS and charter status. So it was 2 weeks ago. It wasn't your one. It was.
No, okay, right. Because mine was approximately 2 weeks ago too. So well, 1st of April. 1st of April. I wasn't. That's 3 weeks ago, isn't it?
No, we've got some more people from the London area, somebody from Glasgow and somebody from Portsmouth.
Right.
We currently have 12 attendees, so I think we'll start the meeting. I'll just say a few words.
Okay.
Welcome everybody to this first session of the Agile Tools for Value Delivery course by Tom Guild. Very grateful that he's cast his workshop series in this form so that we can at least benefit from the useful learning that's in them. And just to point out that all of the 5 courses in this series are now available for booking and registration via the bcsspa.com sorry, bcs-spa.org website. Without further ado, because we've got a lot to get through over the next 3 hours, I will hand over.
Okay, my turn?
Yeah, sure.
Okay, welcome everybody from Norway. The little picture in the upper right hand is taken half an hour ago at my local lake, Kolbolten Lake. My wife and I went for a pre-course walk. So, and we have much bigger lakes called the Oslo Fjord, but they're not within 5 minutes walk. They're like 5 minutes drive. So welcome to the highly abbreviated 2-day workshop course, which is going to be a 3 straight hour lecture course with the possibility of questions at the end and via chat at any time. And even with the possibility of questions afterwards, if you want to email me with a question, make a note of the email there, tom@gilb.com. If you want a copy of the slides, you'll find them there. Might like to take a photograph of the screen or something quick like that. So slides are there, and there are also higher quality copy is at that link there. And we've got about 104 slides. We've got 3 times 60 minutes. So what 1.8 minutes per slide would be good average. In addition, we're offering the book value requirements for free for anybody who wants to follow up in detail. The lecture follows the book, and it uses very many of the slides in the book. So you can consider the lecture as sort of a warm-up. Am I interested in going deeper? And if so, acquire the book and do it at your leisure. Acquire the slides, read them at your leisure. And later, we're pretty sure we'll have a URL distributed to at least the people who came here. I'll probably tweet it. There's Twitter and LinkedIn when it comes out, but be able to see the video, share the video link with friends, or just repeat it, whatever you want. We're proudly sponsored by the SPA Specialist Group and co-sponsored by the Quality Specialist Group, and Margaret Ross, the former chair, I think. Carol Long is chair now, but who sponsored my courses for about 7 or more years at BCS, is listening in to begin with there. Okay, so off we go. Here's a list of the subjects that we've promised to say something about, and they are more or less chapters in the book. There is the link to the book. You're probably going to need to get that slide and extract the link to actually get it. If anybody has any big problems, email me or something. Just for fun, since some people tell me if you give away something for free, people don't think it's worth anything. This is a free download, but I've decided that the normal price from 1st of April is £1,000 for the book. The value is more than £1 million. And however, you lucky lot are getting it for free. By the way, I don't have a publisher yet. If somebody has any really good ideas, we'll probably publish it on my website. So here's part 1. What do we mean by value requirements? It's not an ordinary term. Values are things that stakeholders of a system themselves feel that they value. In other words, they want it, they need it, they get some benefit from it. And these values may or may not turn into requirements. We'll get more deeply into that. It all depends on whether the values are unreasonably expensive or technologically impossible. Then a value from a stakeholder cannot turn into a real requirement for a project. We have some graphical symbols for some of the concepts here in my planning language. An oval is a function, what the system does, and the value is depicted as an arrow, which is actually a scale of measure with increments, where the value is getting more and more and more and more and more. So you'll encounter these symbols quite a lot throughout the lecture. Here's another view of values and stakeholders. In fact, I use this in the April 1st BCS SPA lecture on technoscopes, which we now have a video of. And in fact, we were just before the Corona crisis hit, but while we knew it was coming, we had a class very much like the BCS workshop, and we decided to plan for the coronavirus. So here you see some of the stakeholders we brainstormed. It's not as complete as it might be if we'd spent more time and had more people doing it. We might have more like 100 stakeholders. But from these stakeholders, we tried to derive, what are they interested in? What are their values? And here's the list we came up with. Let's call this list the top 10. There probably are 90 to 100 other things that might be considered, but at some point, if you don't want to get overwhelmed, you have to prioritize and say, what are the most important things to do in the short term, let's just say the coming year, and we'll do the other things when we've done the most important things first. So these, with the arrow symbol, are our values of the stakeholders, and we've even got a little graphical link from each value to one or more different stakeholders. And one stakeholder can have one or more values. And it's quite useful to have digital links where we're displaying, in fact, digital links on this diagram, so you get some impression of the fact that this collect information has about 4 stakeholders, and this stakeholder has about 3 values. Okay, so now if you read the list of, if you read the list of values, you get some idea of what we mean by values. These are just the names of the values, or the tags as we call them. We're going to go deeply in this lecture into the definition of what these things mean, but it gives you some idea of what we're, for example, first thing you might notice is the values are not financial values, which is something you might think when we say the word values. The money and financial comes into our mind straight away. But if you like, these are primarily non-financial values, but they could be financial values, as funding probably is. There are some other requirements types that we're not going to talk much about. They are dealt with thoroughly in a book which we give free copies of on our website and other sources, like the Technoscopes lecture, called Competitive Engineering. So if you want to go deeply into other requirements types, do get your pre-digital copy of Competitive Engineering, or order it from your friend Amazon if you prefer paper. But just to give you some contrast to the value requirements, first we have the most common kind of requirements, which I call function requirements, and they describe what the system does or must do. It's very binary. It either does or does not collect taxes, or test for the coronavirus, or something like that. And these types of requirements are so common that some people just call them the requirements. And then as they mature and realize there's something else there, they might talk about non-functional requirements. I'm sure you've all heard of those. But generally speaking, if we say, what are these non-functional requirements, we might get the word quality, as in the quality specialist group. All the ilities like usability, privacy, security, availability, and things like that. Those would be non-functional requirements. Now, those non-functional requirements are largely covered by the value requirements, but here are some requirements that are not functions. The resource requirements, they are any kind of short-term, long-term, people, time, money ideas that are necessary for building and maintaining the system. And they're pretty important too, because if you don't have enough, you can't do it. So we keep track of them in any system, we make sure we know what the budgets and the deadlines are and make sure that we can really deliver the values within those resource constraints. So those are pretty important. Then we have a number of binary constraints, I call them, like it must be legal in Britain, or design constraints, like you could design it any way you like as long as you use patents from IBM. Binary constraints are like the functions, they're binary, they don't vary on a scale. You either are legal in the UK or you're not legal in the UK, even though some of the banks I know vary a bit in their degree of legality or conformance to regulations, but that's just how it works. Anyway, here's another view of from the competitive engineering book of different classes of requirements we've defined. And so here's the concept of a requirement. Here are the performance requirements, and they basically cover the same thing that we're talking about, the value requirements. How well does the system perform are my values? And that includes qualities and savings of resources and workload capacity, etc. So we're mainly going to be in this area here. We're not going to talk about function requirements, which include things like missions, function targets, constraints. By the way, the asterisk and number here means this is a formally defined term in the glossary in the book, and there's a free link to download a glossary of altogether about 700 terms in the book and outside of the book. Here are some of these other types of requirements that I mentioned that we're not going to go into much detail about in this particular lecture. But here's a little challenge to you all. Enrich your conceptual understanding of different classes of requirements, and we're going to focus on the value requirements or performance requirements, which are mainly quality requirements in this particular lecture. Moving on. Now, a lot of people, the only kinds of requirements they really know about are called user stories. And of course, they're not really requirements, but people treat them as requirements for, say, a Scrum team, and they deliver user stories mainly by delivering code. So I thought I'd comment on them. Now, in one sense, I like user stories because compared to typical function requirements, they are enriched. They have a structure which says, we'll tell you who the user is. That's why it's called a user story. Although, frankly, I think we need to look at more than the user in a system, like the other 50 stakeholders would be interesting, like EU laws or something like that, even after Brexit. So I think we probably ought to call these stakeholder stories. There's a thought. What are the stories of the stakeholders? And the story is a sort of requirement, but whether it is in fact a function requirement, a value requirement, or a design is not clear. It can be anything they want, and we haven't really classified those. But as long as it can be programmed by programmers, people are pretty happy with that. And then there's a third element, a justification in order to achieve something or because, and I think that's very important. You know, why is that requirement justified? So I like the structure a lot, and I use this structure a lot in my requirements. In fact, a much richer structure than that. But what I'm unhappy about is this part, the story, the lack of formality in doing it, and the fact that anything goes, whether it's a design or a requirement or a value requirement. What I believe is that the user stories should be considered what I today call an ambition level, and we'll be talking in more detail about that, which is a rough overview of what I want. And then we ought to go into more detail, for example, by defining a scale of measure, which we're going to go into much more detail about immediately. And having defined the concept with a scale of measure, we might be more specific about exactly how good we want to be, like we want to do something within 6 minutes for expert complex tasks and things like that. So we're going to go into all of that in more detail. So I'm going to say that nothing wrong with user stories as long as we, in a serious, complex, and large system, we take the time and trouble to define it much better so it cannot be misunderstood, and we can, for example, pull tricks like decompose it for incremental delivery, so we can decompose the user story itself. We'll be talking about that very explicitly in a few moments. Anyway, by the way, I'm working out how to do user stories in my planning language, and if anybody has a serious interest, like they're going to write a paper on it or do something more advanced for user stories for their business, if they take contact with me, I'll share what I'm working on, probably be motivated to share more. But very roughly, I'm saying user story is just an overview or a headline, and as it is currently written by most people, it doesn't contain enough detail to avoid misunderstandings and to specifically deliver the values we want. So part 2 of there's about 18 parts. Here's a view of this, this arrow being our value or performance requirement. And there are 3 major elements I'd like to point out, and we'll talk more about them all. First, there's the idea of a lower point on the scale, which we can call a numeric constraint or a worst case. We also call it a tolerable level. And what that is the borderline between what is barely acceptable, what we can barely live with if we must. And on the other side of it, here, we have what we can call a failure territory. So in a sense, this constraint number defines very precisely the borderline between failure of a value, which is usually, if it's a critical value, the same as failure of a system. Okay, and that means failure of your project to deliver. So it's a pretty important idea that we have a number which defines the failure point. Now, so our first priority is to design and deliver or maybe make use of an existing system which is above this critical level and brings us into not failed territory or tolerable territory. At this other end of the arrow, we have a thing we call a target, and that's the target is what we're aiming to deliver by some deadline under some conditions. And by hitting the target, we've also defined the concept of success for and enough delivery and enough design and enough coding and enough testing sufficient. We've defined done, in fact. And but that's a precise number. And if we achieve that, we have succeeded. We might even pay a sub-supplier full pay. We'll talk about that later. And if you go beyond that, well, nobody's asking for it yet, and it might be a waste of your resources, and maybe the resources you could use to go beyond this might be better placed in delivering other values that are not yet at their target level. Now, the B is for benchmark, and we'll talk more about them in detail, but that might be where, let's say that's how good our existing or older system or older product is now. That's where we're starting from. So what we're doing is we're comparing, say we're starting from there, but we're going to get at least to there. Otherwise, there's no point in starting this project. And we really want to get all the way over there to our target level. And if so, we will consider this value delivery process to be a success. Now, notice this is an incremental scale, and we can and will normally do incremental sprints or deliveries. But these are not sprints of developing code, as would be more typical in Scrum. These are developing your system. And you could be doing things like enhancing the motivation or contracts or organizational structure or database organization. And you might not be delivering any code whatsoever, or you might be reusing code that already exists. So this is not about delivering code at all, although it might be on some occasions in software, but it's about doing whatever it takes to deliver the values you want. That's the kind of systems thinking we're doing, not just programming thinking, which I'm afraid is the problem in IT and Agile as we see it today.
Tom, just before you go on.
Yes.
Javier has pointed out that a user story needs to have acceptance criteria to be complete. How do you see the relationship between the traditional kind of acceptance criteria on a user story and this scale of value that you've outlined just
right. I'm also going to comment user story much later in the slide set here, but if the user story is as imprecisely and ambiguously defined as I normally find that it is, then it's not much good for developing acceptance tests. In other words, the acceptance tests could misinterpret the user story and test something else. Okay, so what I'm encouraging in this entire talk is to start with the user story, if you like, but develop its clarity and its precision so that both the developers deliver the more precise thing you've asked for and the testers test the same thing. In other words, the requirement cannot be misunderstood is the objective here. That's my short answer. Is that okay, Imo?
Well, I think the acceptance criteria are normally part of the user story itself, so they kind of clarify the requirement that's implicit in.
Okay, I think I'd need to see examples of what you're talking about because I don't see that in what I'm looking at. But I would suspect, and we can discuss this by email if you like, that these so-called acceptance tests are not as clear and precise as they could be with the methods we're talking about here. So maybe by the end of this lecture, you will in fact have a recipe for developing the requirements so it's much easier to specify what the user test is. I have a thing coming up called a meter, which is in fact the test process definition. But the detailed definition, like the one I'm showing here, is the exact thing. We're gonna test that we've reached the tolerable level, 80%, and we're going to test that we've reached the wish level, which is a target of success of 98%. Those are the kind of things we do not normally find in any user story acceptance test. They're not even focusing on value or quality at all. It's not on the agenda. So I think we're talking about two entirely different things, but I'm quite happy to take a look at what you're talking about because I don't recall having seen it, and then we'll have a discussion on that basis. Okay?
Yeah,
Did
sure.
I hear okay? Oh, okay. Okay. Right. Okay. So mainly this lecture is going to derive ideas from a planning language called Planguage, which I've been developing my whole life. It is defined in that competitive engineering book. That's really the rules or standards for Planguage. And so here's a simple, oversimplified, of course, example of the benchmark, constraint, and target that I was talking about here. We start off with something called security, and we want better security. And some people stop there, something like better security. But in my world, I believe we must absolutely, unconditionally, and always define a scale of measure for security. Now, most people cannot do that for things like security, user friendliness, and most qualities. I know because they come on my courses and they tell me they don't know how to do that. So we're going to talk a lot about the idea of defining a variable, in this case, a value requirement, by first defining a scale of measure. And here's a very simple idea of a scale of measure, the percentage probability of detecting a hacker within 5 seconds. Now, that's oversimplified, but at least it gives a clear idea of the idea of a scale of measure. And then on that scale of measure, we have 3 points. These are the same 3 points we're talking about here. And first is the status. So what's the probability we'll detect a hacker within 5 seconds now? And let's just say 10% last year. Not very good. 90% of the hackers are going to be able to be in there more than 5 seconds. What's the minimum we really want to feel comfortable that we've actually got better security? What is the definition of better in better security? And I've put a number there, 80% by the end of this year. In other words, how good by when? for example, in infinite time wouldn't be a very interesting deadline for that. And just somewhat better than 10% is not very precise. So the word better isn't good enough. 80 is clearly 8 times better, and we know when. But this is the minimum, the worst acceptable case. And then the wish level, which is what the stakeholder would feel very happy with and comfortable and feel successful, 98% by the end of year, very much better, very much more complete than 80%. We might not be able to get there, but we can wish for it, and we can say we would be very, very happy if we got there. So this is a simple example of taking something as simple as better security and turning it into language or planning language with a scale, and then 3 different types of points on the scale, all of which we're going to discuss in more detail in the rest of the lecture. So first I'm going to discuss scales and a subset of them called scale parameters. Now scale is like the big idea. If you, from this 3-hour lecture, got one idea, I can put scales of measure on all values and qualities. I can always do it. Then you'd come away with a very powerful idea to help you in the rest of your professional life. So scale is the core technique I really want to teach. We have learned that we can always, and we should always, quantify all of these value requirements. That includes absolutely all qualities. No ifs or buts, no exceptions. The fact that you don't know how to do it is immaterial. If you Google it, you'll find a million examples of other people who do know how to do it. Google security metrics, usability metrics, and you'll find that lots of people know how to do it, even if you don't. So your ignorance of how to do it is not a good excuse for not doing it. You have to do it because you have to be clear to the testers and the developers and the managers and the architects and everybody else. And better security is not good enough. So using the scale, we have formally defined the concept much better than just saying security. And we can then define success with, for example, a wish level. Okay, we can also define failure levels by using the tolerable level, like down here. And now, what we're doing here, we're not really focused on measurement yet, or certainly not mathematics and statistics yet. We're focused on clarity of communication between people on your team and your stakeholders so that nobody can misunderstand a critical value. And I hope we can all agree that the ideal that nobody can misunderstand who's on the team is a good one, and that the very typical and widespread requirement types that we see everywhere, including on most user stories, like better security or much better security, totally fail this test of being clear and unambiguous to all people. So how are we going to break out of that? And I'm giving you a specific method for breaking out of it: quantify it. Okay. By the way, once you've got it well defined and clear, especially if it's numeric, you've laid the basis for contracting with sub-suppliers for delivery of this value and concomitant reward or payment for delivery of values, which I think is a very good idea. In geographically spread projects where people are working from all over the world or from their home office in London, this written clarity is very important. You know, people are not going to have lunch with each other and get to know each other that way. They have to have it in writing, and it has to be clear in writing, not unclear, like better security in writing. Now, the scale is itself what I call a quantification idea, like miles per hour. It is not a measurement idea like a speedometer, okay? And we'll get back to that later. These are two related but distinctly different things. And I, for one, was confused when I was much younger and had to get straightened out. And I keep on finding people say it's too costly to measure therefore we cannot quantify is an illogical statement. So we got to get, quantification is all about being clear, and measurement is about getting feedback after every sprint or increment in your project, two different things. But a meter relates directly to the quantification idea. So you have to specify the scale before you can specify your measurement process. This is a very powerful and useful idea. Now, this scale, we're going to write it once and reuse it many times, as we'll see, like for maybe 10 different purposes, short-term, long-term. So it's we take our time and we write a really good scale, because every time we reuse it, then we have something clear and usable. We don't shorten it and hope people understand what we mean and take a chance there. Here's a report of why IT projects fail, and inaccurate gathering of requirements, 39%, change in the project objectives, 36%, inadequate vision, 30%, and poor communication, 30%. So these causes of project failure are what I'm trying to deal with in this course and with these methods. I'm trying to enhance the clarity and communication of requirements so we don't fail to deliver what people really want, which is the clear definition we get when we work on it. Now, scales. A scale has some characteristics. One thing is it must allow us to put a number on it. The numbers must have meaning. So if you write a scale and you say, does 42 have any meaning? And the answer is no, then you don't have a scale. Okay, quite simply. And we're not trying to be short. We're trying to be rich enough to so that nobody can possibly misunderstand what the scale is. Now, these are oversimplified examples of scales, but they'll do. A typical scale is about 10 words long, not 100 and not 1 or 2. We can start there. We'll be giving plenty of examples of scales. Now, a scale should also be intelligible to people who are amongst your stakeholders, working in the domain, whether it's banking or London transport or something like that. The scale should also reflect the value that these domain specialists and stakeholders believe in. In other words, one of the big errors in quantification is people pick a quantification which is easy to measure, but doesn't make much sense to the people in the domain. We'll talk more about that later, but that's in other words, it isn't just any scale that quantifies we want. We want a scale that really reflects and correlates very well with the value that our core stakeholders would say, that's my value and that's a very good measure. That's a key idea between good scales and bad scales. Now, what I find when I look at almost anybody's requirements are statements of, let's call it ambition. Here's a simple example. Before performance, Tesla prefers to focus on safety first. A source of that, Elon Musk, a certain date. Now, this type of content is typical of all the user stories I've seen, with extremely few exceptions. Now, the problem with these is it's okay at a high level. Sometimes we call it a headline, but a headline doesn't give all the detail. It's just a short format. And the other problem is that it doesn't give us anything we can measure and watch the incremental delivery of the value. So I call this an ambition level, and typically it is spouted by the top honcho. It is spouted by the politicians. It's all over the place. The problem in IT requirements is people don't take the time and effort to decode this and make it clear, measurable, unambiguous for all the other people that need to do it. So I think it's okay that a top politician says things like this, but people are going to build a serious system like handling the coronavirus in Britain, for example, need to go into more detail about it. So I took it as an exercise to decode this ambition level to a scale. Now, the scale isn't much longer than the ambition level, but it suddenly brings us into numeric territory. and it satisfies a large number of other criteria, which I have here. And I won't read them out in detail, but the point is I've got to come up with a scale that other people would think is a good scale and really reflects their values. So in this case, I actually chose a scale that is a European standard in the area, and is used by people like Elon Musk to report how good their safety is in their cars. So it probably satisfies the criteria, but you don't know until you ask them. They might say, I want an international standard, not just a European standard, or I want a British standard, or whatever. But we can, at least we have a very much more specific idea of what this safety means. And we have a clear idea of how to measure it, and indeed examples of it being measured in practice. So there, I believe that it's quite an art to turn rough political talk, ambition levels, or user stories, same level as far as I'm concerned, into a scale of measure. People have learned the art, and I try to train people on the courses to do it. That's what the workshop does. It says to people, okay, you take this and now turn it into a scale. And if they haven't done it properly, I, as the instructor in the BCS courses, tell them this is not a good enough scale, and here's why. But that's the first step of clarification, is turning it into a scale of measure. Now, here's another view of all of this. This is from the Competitive Engineering book, from chapter 5. Here's a free download of chapter 5, which shows you how to quantify all of these qualities like usability and security and maintainability, etc., in practice. But it also does another thing. It shows that some of these qualities are actually subsets of a higher level of quality. In other words, availability is decomposed to reliability, maintainability, and integrity. Integrity is decomposed into threat and security. Now, what's that? Well, it's a way of organizing knowledge about things, and it's a way of, in this case, we've got almost a standard for the qualities that occur in almost every project, and a standard for measuring them. This is also a method for arriving at scales. Sometimes you start at a certain level like adaptability, and you say, well, I can't think of any scale for adaptability. But you decompose it and say, well, what are two constituent parts of adaptability? Flexibility and upgradability. Okay, can I think of a scale for upgradability? No, let me decompose it once more. Okay, installability, portability, and provability. Can I think of a scale there? Well, long story short, the more you decompose, the more likely you can it gets specific, and you can think of a specific scale of measure, which is exactly how I developed these scales of measure published in the book. So this is actually a method, I call it Cartesian decomposition, i.e. René Descartes, French philosopher, who said that to understand some things, you need to decompose them into their constituent parts, and then all will be a little bit clearer. Okay, so think of this as a way of getting scales of measure. Either you look them up in my book or on the internet. Portability metrics would be a keyword for looking up that. And or you develop them by decomposing things that are not in the book. They're new and special and you've never seen them before. But if you decompose them, you will usually arrive at a level where quantification is obvious, as they say in the Reliability Handbook by Dr. Duran. So here's something I was alluding to earlier, the idea that it isn't just having a quantification of any kind. Some quantifications are misleading, irrelevant, and so we need to have good and useful scales of measure, and that means they have to be relevant to what the stakeholders think is relevant. The stakeholder have to buy in and say that's a very good measure of what, and a very good definition of what I am interested in. And you need to go back to your stakeholders and talk with them and show them your scale and tell them that if they don't like that scale, they should talk with you about it. Okay. So in other words, scales need to be highly correlated to the real environment, to the causes and effects that real people in the real environment care about. Okay. Now we're going to go on to a specialist subject, a very powerful trick which I've developed through the years, and I use every time I write scales. So I think it's something people ought to learn on day one and practice all the time. And indeed, on the BCS courses, we do that every time. I say, I have a thing called a scale parameter. So that's something in the scale. Here, let's read this security scale. Percentage of known annual attack types, that's a scale parameter. Having potential or real effects, that's a scale parameter. On specific stakeholders, that's a scale parameter. And we have a language which says if you put it in square brackets, it's a scale parameter. And what does that mean? It means it is a generic idea that needs definition, like what are the different kinds of stakeholders, attackers, clients of attackers, attack on individual victims, corporate victims, government victims. Those are the different kinds of stakeholders. And what we're doing is we're defining security in terms of scale. We're then defining this security in terms of attack types, potential or real effects, and stakeholders. And then we're defining stakeholders in these terms. So there are several levels of definition, but we're getting better and better definition, more and more tailored to this stakeholder, this domain, what you're working on definition. And there are very many good uses of doing it this way. I'll spell them out as we go along. But for the moment, the main point is it's a way of defining things in no uncertain terms so nobody can misunderstand. Here for the vehicle safety example is another example. The scale is a star rating number for a person type and a certain group of car specs for a certain group of safety equipment, which may be optional, for a certain alternative model validity, for a certain publication date, and a rating agency. So these are all scale parameters which are important in this domain for understanding exactly what we're talking about. But so the first thing I need to point out, if you want to learn, this is a modeling language. Everything we're talking, language is a modeling language. We are modeling the real environment of the critical variables called value requirements. And if you're modeling trivial systems, you don't need this. But if you're doing planning for the coronavirus or Brexit or something like that, it is non-trivial, and you do need this stuff for modeling all the critical things you have to think about, and for forcing people to think about all those things they must think about, otherwise the system might fail, or you'll learn too late that you've forgotten them. Okay. It also becomes a critical tool for prioritizing the sprints or value deliveries we are going to do early, and the ones we can put off until later. In other words, it gives us a tool for doing critical stuff early. You'll notice that in the whole handling internationally of the coronavirus, there's an awful lot of this prioritizing, for example, people of a certain age in old age homes who have critical diseases. That's exactly, and there's where we need to hit first so they don't die in the first few weeks while we're working out what we're going to do with 6-year-old children in kindergarten. So it's exactly the decomposition so we can pull out the critical things first and do something with them immediately before they die. And so, in other words, this is a good common sense way of thinking for mature planners, but immature planners do not think this way. They overgeneralize, and they learn too late that the people in the old age homes have died in vast numbers, as they do in some countries, but not others. Okay, right. More about scale parameters. Here's a little example of how we use it in practice. Here's that vehicle safety thing I had on the previous slide. We've used it to define the scale. Now I have a wish. So this is my success level for a given stakeholder. And I wish to get 5 stars on this scale of measure. That's the star rating. by next year, that's the deadline. So we have individual deadlines for each wish. Sorry, not one deadline for the whole project. This is where we can do things in near time, medium time, and long term by having different deadlines for different sets of critical factors. Anyway, person type, all of them. Car specs, a set of them, rear wheel drive, 4-door, 2019 model. Here's the safety equipment list that we're looking at. Here is an alternative model validity, publication date, and the rating agency, all of them. So this, in other words, what we're doing is we're choosing exactly which parameters in detail we're going to apply where we wish to get 5 stars by next year. So you'll notice this is a hell of a lot more definition than most any user story has, or any user story test specification. And exactly this gives you a much more detailed and concrete list of test specification elements, IMO, that so we know exactly what to test and what not to bother to test. So we're looking at testing as well as development of the system here. More about scale parameters. The first time you see this, it's a lot more complicated than a simple user story, that's for sure, but it might be the necessary minimum of complication to avoid total failure of your project. Things should be as simple as possible, but no simpler, it has been said. And for problems like coronavirus or Brexit, this is the level of complexity you need to go to avoid failure in your effort. Again, if you're just writing some code for a friend this week, don't bother, just write the code and see how it works. And I'm afraid that some of the methods we have are at that primitive level, and that's not good enough for the very many large complex IT systems we're dealing with in Britain and the world. So I view this not as complicated, but in fact, I'll argue the opposite. It's a way of simplifying very complex problems. So here's the very complex problem. We have all of these variables which have all of these different variations, and this is just one value amongst 10. That's pretty complicated. But by spelling out exactly what we want to do by next year, this stuff, we've now eliminated from the complex picture we might look at all those things we might do the year after and the year after and the year after in a very long project. We simplify. We can focus on this stuff we have to do this year, by next year, and this stuff we have to test by next year, and this stuff we have to design. So this simplifies what we have to look at, which this may be only 1% of a complex system, and we can focus but it is critical, and we need to do it early. So we can focus our energy on getting this right, and just don't bother to look at everything else. And you might say, what happens if we don't consider everything else? And I say, if you try to consider everything else, people will die in droves in the old age homes while you're considering it. You can't afford to do it. You have to pick out the critical stuff and deal with it and learn from that. And then when you have enough resources, you can start looking at the things that follow after this, which could be the same year, other people, but it might be after next year you start looking at it. And that does work. There's no law saying you have to consider everything simultaneously or you can't make the system work. That's a fear many people have, painting themselves into a corner. It is not relevant, and there are techniques which mean that you can avoid having problems like that, which I won't get into, but it's under the heading of decomposition, which I will talk about later. So we're trying to extract something simple, which we can work on, and we're trying to deliver some high value improvements early. I call this whole method agile as it should be. And I'm talking to people who do conventional Scrum and things like that. And I don't think that's agile as it should be. I think it's a dangerous kind of agile. And this is Agile as it should be. It's dividing things up into sprints in a more intelligent way than is currently practiced by most teachings. Okay. Another thing that's happening here is by doing something very specific in the short term, you not only deliver something in the short term, save the old people in the old people's homes, but you're going to learn whether your architecture or designs actually work or not. And you can generalize that things that do work for doing similar things in the early stages are more likely to be successful in later stages, and things that do not work in early stages are less likely to work in later stages. So you're actually reducing the complexity of having, say, 1,000 potential designs or strategies, and you very quickly, like in a few weeks, learn one or two strategies that really do work and probably will work as you scale up or change. So that's another reason why we are simplifying things before we commit to scaling up. So I gave you my library from the Competitive Engineering book, chapter 5, and we've built a tool, but anybody could build their own tool for this too, where we've taken the library and put the scales of measure for these concepts in the library. So all we have to do is click on one of them, like availability, subset maintainability, and we automatically get the scale of measure framework or generic framework that's in the book. You can get it from there, but it's also in the tool. So this is what I'm trying to show is an example of, and we can build this library by adding anything we are interested in our domain. So this is called corporate learning, where we learn scales of measure from our London transport domain, and we put them in the library, and good things will hopefully get reused or at least studied before we reinvent the wheel. Now, this has 3 scale parameters: system, failure type, and condition. Now, let's take one more step. I've used this from the scale library, but in fact, when the system says, okay, you've got a thing called system, now what systems are you thinking about? And I said, well, databases, central hardware, internet, application software, OS software. I've defined that. It's not in the library. We maybe could put things like that. We definitely can put things like that in the library and keep them there. But I've defined that locally for my domain. So this is like general knowledge of how to define maintainability. This is maybe specific knowledge for example, an IT system. Same thing here. I'm interested in these failure types: power failure, sabotage, component fault, and I can add things as I learn that I need to add things. So there was these definitions give more specific and more tailored and more local definitions, but we have decided to start from a generic reuse of the idea of how do you define a maintainability idea. Okay, so we can build it into a tool or any kind of automated system we have, or we can simply look it up in the chapter 5 of the handbook, for example. So here's a set from, this is from a BCS quality group course of exactly the same type we were planning to hold in March, the workshop on value planning, and September 2017. And we chose the London congestion for air quality problem to work on. And these are the top 10 values requirements we came up with, air quality, not surprisingly, being one of them. And none of these would come as any surprise. But we can't just put the word better in front of all of these and say that those are our requirements, because as I've tried to demonstrate, that is highly ambiguous, unclear, and will not be understood the same way by test planners or developers or architects or anybody else. Anybody who tries to decode these will come up with different interpretations. Almost nobody ever comes up with the same interpretation of ambiguous terms like these. So we've got to as requirements planners, we've got to do the clarification ourselves. So here is air quality, and the ambition level for air quality, in other words, the high level notion, drastically improve air quality in London to acceptable legal levels as stated in the Paris Accord, also known as Paris. That's not bad. That's probably, if you ask the mayor of London what he wants, he might say something like this. But drastically improve air quality. Well. What does that mean? How drastic? What number is the drastic number? And what is air quality, etc. So we then move on and say, step 2, define a scale of measure. So here's what my BCS class did. Number of persons, parameter, who reside in London boroughs from dying from exposure over time to pollution per year in an area like Camden or something like that. Okay. I'm going to go and show more detail in the next slide about this scale, but let's skim through here. Meter is taking a stab at how might we measure this in practice. So it's specifying a test process, the beginning of test planning. Status is one of these benchmarks we talked about earlier, and we're going to talk about more later. How bad is it now? Okay, very useful to know where you are before you decide what improvement means, or drastic improvement. So drastic improvement is in relation to this number, not your misunderstanding or your wrong understanding of the status. Here are 2 different statuses, one for all types of pollution and one for nitric oxide, I guess NO2 is, okay, which is quite different, interestingly enough. Therefore, drastic improvement from this number for pollution in general, but drastic improvement from this number for nitric oxide. Here are 2 tolerable levels, again, for different time frames, 5 years and 1 year, and different delivery dates, 2022 and 2020. These are the minimum levels. Notice the rich, these are requirements. So notice the rich requirement possibility by using all these parameters. We could have 25 different tolerable levels using all the combinations we have of the scale, which we'll see on the next slide. The goals are commitments by the project. We promise we have the technology and resources to do it. These are the levels these are success levels for 2028, and this is a success level, somewhat better, for 2029 for the Greater London area for NO2 specifically. And here's something we'll look at too, the stretch level, which is going beyond the success level, is something we're not quite sure we can do. We're not sure it's technologically or economically possible, but it would be nice if we could. And here we're naming the, in this case, stakeholder mayor of London, and we're writing down some assumptions. So this is a example developed on the BCS course we talked about of the air quality value requirements. So now you're looking at something very much more realistic and detailed, and you'll see, you can just compare it with any user story you ever saw or any test plan you ever saw, and see that this is a lot more specific. Going to the next slide, it's the air quality again, except I'm taking the scale, which was a one-liner there, and I'm clicking on it and exploding it into a window, in other words, more detail. So here's the scale we saw in the one-liner, but here is some detail about all of these scale parameters, like persons are adult, child, adolescent, senior, and the pollution is CO, CO2, NO2, carcinogens, ... means we think there are some more, but we haven't had time to fill them in. And here's the time definition. So this is a much fuller definition of what the scale is. And now you notice what we're doing. We're not only defining, we're not only quantifying, we are structuring the idea of air quality. Okay, so structure means the structure says there is a scale. That's one part of the structure, and that scale has scale parameters, and they have sub-definitions. That's another part of the structure. So we make things clearer not only by quantification, but also by structuring, by decomposition, as in Descartes' decomposition. This is similar to Descartes' decomposition of an idea. Okay, part 4, and we've used about the first hour. And symbolically, if you're listening to the video, you can turn it off and go take a 15-minute break. I believe in breaks every hour, but right now we're just going to run straight through. And but anybody can walk in and out, get themselves a glass of water or something like that. So this is vodka, actually. No, I'm just joking.
We had one thought here from a member of the audience. The scale that you were showing just now is kind of counterintuitive because it shows higher values in the goal than in the tolerable level. Yeah, so you've got a status of 1.5K, for example, and a wish of 100.
That's right.
But tolerable. You see, so until you actually decompose to see what the the individual.
Now, two things.
Doesn't make sense.
It all depends on the date, among other things, and it all depends on the specification, whether this is really higher or lower than anything else. Okay, so that's the first remark. You've got to look at what set of things you have here and make sure they're comparable, and then you have to look at the date and make sure they're comparable. Now, if you really did have an inconsistency there, good, you've discovered an inconsistency and you need to work on that and correct it. So in other words, maybe there is and maybe there isn't an inconsistency. Remember, this is student work at a BCS course, so it's not officially approved by the Mayor of London. So there could indeed be an inconsistency that we can see through this structure, but there could just be the misconception of inconsistency because people are not reading the detail. And by the way, all of these one-liners open into a window with more detail, which I'm not showing you yet. So you might not even have enough. Here's all the detail for this goal, 950, which is the same as this goal down here. But we have to look at the detail to know that it's inconsistent. Yeah, but getting worse could be inconsistent. Sometimes getting worse is a conscious sacrifice in order to save resources for the benefit of other values. So the getting worse as a plan could in fact be a plan with justification. We don't know that until we see the justification. But that's what, sacrificing a piece in chess in order to checkmate the person on the next move is a well-known way of getting worse before things get better. Okay, Imo?
Thank you.
Okay. Well, part 4 of 18, 2 more hours to go. I'm going to go into more detail about some of these things. So we have this thing we call benchmarks. And benchmarks are systems analysis. And in theory, the person doing the benchmarks was, in many of your environments, will be called something like a business analyst. Okay? And these are, you're collecting information about the environment of the stakeholders. Okay? Maybe by interacting with the stakeholders, observing them, or researching them. And now the benchmarks are not requirements, but we are plugging them into the requirement specification side by side with the actual requirements. Now, most methods of doing requirements don't do that. For example, your typical user story doesn't give a lot of information about how bad things are or how good your competitors are or what the record is, which we're going to talk about here. They don't even try. They may have done that analysis work preliminary to stating the user story, but they show no sign of it. They do not give you the information. I believe that the benchmark information should be quantified, should be detailed, like on what date, by whom, and should be contained in the overall requirement specification. And by the way, I'm talking about one of these, okay? And here is a benchmark, 2 benchmarks called status. Sorry, there we go. Okay, so and I believe that should be brought in so that it is available for all people at all times, considering setting and adjusting the requirements. That's a very important thought. The idea that systems analysis or business analysis information is brought into the requirement specification in detail and is available for anybody who wants to know. They don't have to go to a separate paper on the systems analysis of the systems, which may be elsewhere, may even not be available for them at all. And to know what are the benchmarks. It should be available for anybody doing any kind of requirements work. Okay. So now here is one type of requirement. We showed one earlier called the status. Okay, I'll get back to that. But here we have one called the past level. Now the definition of past level is it's historical, it's stable, it happened once, and we are interested in it. Now notice we get very precise about the level and a reminder of the scale, and we use the scale parameters like, you know, and we even have a date. So we've got lots of information about that benchmark. Okay, so that's one type, quite simply past level. Okay. Now the status level is similar to past, except it's far more dynamic. Status is almost like writing a time and space series of how things were or might come to be in the, actually status is always were in the past tense, okay? So if we're in Agile and we've just done a sprint, status might be the measurement of what just happened on the previous sprint. In other words, how good are we to date with delivering the value? What is it we have left to deliver? How far along are we? So status is very much about dynamic step-by-step Agile stuff, whereas past could be a waterfall model way of thinking about systems analysis. But we're doing systems analysis step-by-step, sprint-by-sprint in Agile and getting feedback and learning constantly. So that gets, but we feed that directly into the updated requirement specification, so that anybody considering what they're going to do in the future, any modification, is in your face, forcefully aware of what has happened to now in the system we have been developing for maybe 50 weeks or something like that. Okay, and again, whether the number is comparable depends on whether the scale parameters are comparable, but the date or time will be different from a future wish and a past status, of course. Now here's another benchmark. We haven't talked about it earlier. We call it the record level. This is like an Olympic record or a Guinness Book of Records record. It is an extreme achieved for certain parameter conditions at a certain time. It has really been achieved. That means technology for achieving it does exist. And if you use that technology, if it wasn't a secret, you might be able to achieve that record potentially. Maybe not for other reasons, but nobody can say it cannot be done, because in fact it has been done. And so you know, record serves a number of purposes. One is giving you some idea of how good you could set your goals to be realistically. And if you set your goal way beyond the record, maybe that is a signal that you set an unrealistic goal, and a computer looking at this set of information might tell you your wish is 500 times better than the world record. Maybe you ought to rethink one or the other. Okay, things just don't get that much better that fast. Okay, so another thing we're doing with the record, we're challenging people to show their expertise in this area. In any domain, experts know the records, you'll find. And if people don't know the record level, the number that set the record, then they are not experts, and maybe you should not use their advice. Maybe they're not qualified to do this work of setting the requirements. Hint, hint. Okay. Now, you should be able to Google the records, generally speaking, if you don't know them. And but it's an interesting exercise, even just to ask, what is the best that's ever been done about this type of pollution in a large city like London? Is a very interesting thing to ask. And then the next question is, how did they do it in Wuhan by reducing the virus, etc.? You learn from records. But again, the record is not a requirement, but like all other benchmarks, it is stated, integrated into the requirement specification, because the information helps us reason and discuss things like what future requirements we really want to have. Here's another benchmark. It's called the trend level. Now, the past, status, and record are all looking at something that happened in the past. But the trend specifically looks ahead to the future. Call it looking out the front window at the emerging scene here. This is the kind of thing that marketing people like to do, like how bad is our product getting and how good are the competitor products getting. So you can probably expect some help from and some interest from marketing people in establishing trends. Now, if the trend is that your competitor or another city is getting going to get much better than you are even planning to do by the time your wish kicks in, then maybe you ought to think twice about whether you're being ambitious enough to beat your competitor or to be as good as other cities are trying to be. Okay, so in other words, as a part of your planning process, you could say, what future trends should we be looking at and knowing about and keeping, maybe bringing into our specification as they become available, so that we don't make the mistake of planning to be much worse than our competitor, planning to be much worse than our enemy, planning to be much worse than the technology will in fact allow economically. Okay, so it's a very challenging and good question. Again, people who do not understand the trends are not experts, and they should probably not be part of your planning team. They don't know what they're doing. Okay, you don't have to know, but you have to know how to know. In other words, how to look it up, how to access the information, whether it's Googling or asking a friend who is expert, or having a chat with your friendly marketing specialists. One short story about trend is Kai and I developed the trend as we were landing in Stockholm, going to work for Ericsson, and thought it was a good idea. He actually suggested it and pushed me to recognize it wasn't in our kit. And we suggested it then to Ericsson, our client, who immediately thought it was a good idea and put it into use. And that sort of proved that there was a need and it was useful, and smart clients know exactly what to do with a trend. Part 5. Now, constraints. So these are constraints on the scale of measure. They are basically the dividing point between being intolerable in some sense and being tolerable in another sense. And in a sense, we draw a line saying that anything at that point or better is officially, maybe even contractually, legally tolerable, okay. And anything below that line is declared officially, maybe contractually, maybe payment-wise, to be intolerable. Okay, so what we're doing is we're defining failure clearly in advance, so that anybody doing, say, the architecture doesn't bring in any architecture that could fail. They're made aware of the fact that whatever you do, don't bring in architecture that could land here. We just not going to take a chance. Bring in architecture that at least lands here and in fact hopefully brings us to our goal. Okay, so here's another picture of the same thing. once we've decided what our tolerable levels are, and there can be many for different parameters and different times, and what our goals are, these are success criteria, okay, then we actually can use these numbers and the parameters, the structure, to prioritize. In other words, the development team's first priority is to deliver tolerable levels of all 10 or more critical values. Okay, that's first priority. It'd be bad prioritization to spend 99% of your time and effort to reach the goal of one of your critical values, whereas one or more were totally failing. That if one value fails, it generally speaking means the entire system is unacceptable and fails. So it doesn't help if your brain is working, if your heart isn't pumping, and vice versa. Okay, we have to simultaneously, all your critical factors have to be okay or tolerable at the very least. And so your second priority, once your top 10 have reached the tolerable level, these are agile sprints, delivering more and more and more until all 10 are at the tolerable level. Then your second priority kicks in, where you're working to move all 10 of them towards their short-term goal levels. There could be long-term goal levels, but your short-term goal levels first. Your second priority would be the longer-term goal levels, of course. And okay, so then your third priority, once you've reached your goal levels, is to go for longer-term goal levels or special other combinations of scale parameter goal levels, like in different communities with different clients in different markets and that kind of thing. In other words, different types of success. But in very simple terms, first priority, become livable, tolerable, functional, if you like. Second priority, become successful at some level with some definition. And your third priority, become more successful, okay? And what this does is it feeds to the, if you like, the project manager or the project team as a self-managed team, to gives them instructions as to what to prioritize by the numbers and by the scale parameter structures in the requirements. So here's a simple example of multiple levels. So as I've hinted, once you have a scale, we can have status and tolerable and wish and record and all these things, but we can also have multiples of any one of these, i.e. multiple statuses, multiple tolerables. Here's an example: multiple wishes, multiple records. Multiple means different numbers, probably with different dates, and probably with different parameters. There are no parameters in this simplified example. There are no parameters in the scale. Keep it simple. Okay, but the idea I want to get across here is this: we don't just have one status, one tolerable, one wish, one record. We can have any number, like 100 if you must, not that anybody really would, but certainly 2 or more is probably quite interesting for any system. And the more large-scale, long-term, complex the system is, the more you're going to have multiple ones of these. Now, every one of these implicitly relates to and reuses the scale of measure. So this scale is tightly attached to all of these, and we don't restate or have to restate the scale. It's stated once and for all and reused every time we come up with a level concept. Part 6. Requirement level targets. So this is where we define success in our targets. But the targets, we have different types of targets: wish, goal, and stretch. We've talked about wish and goal very lightly, and we haven't talked about stretch at all. We will. And every one of these can have different deadlines, in other words, long-term, short-term, medium-term, and different parameter conditions. Okay. So here, now clear targets begin with clear scales, point already made. Here's an example of a scale for security. And here are the different parameters defined in more detail. Nice example. Here's the ambition level, or if you like, a user story. I want the best security to fight hackers and protect my customers and company. Very nice, thank you. But here's the detail you need for example, protecting the hackers against a Brexit system or national health system. This will not protect very well against the hackers in the national health system. So we've already talked about the wish very lightly. Let's go into slightly more detail. So wish is a stakeholder wish. It means one of your 50 stakeholders, or maybe 2 or 3, needs or believes they want some level of this quality. It may be a level you already have in the old system. Doesn't always have to be an improved level, but it could be an improvement on the current level you have, and it could be a vast improvement on the current level. It could be anywhere on the scale, but whatever, they wish to have it, and we pin it down and make sure they get it. Now, the thing about the wish is, it is exactly what the name implies. They wish, but we as project have not yet granted their wish. Why not? Well, it could be because the wish is technologically impossible. So I wish to get to the moon and back in 5 seconds. I really do wish I could. Wouldn't that be cool? But if anybody knows how to do it, let me and Elon Musk know. Okay, so I can wish, but I cannot make it. My 5-year project, getting to the moon and back in 5 seconds. It's probably not going to happen. Not even using Elon Musk and SpaceX in the coming 5 years. Getting there and back in 5 weeks, we can talk about, right? That 5 seconds made all the difference to the wish. Okay, so wish is not a required requirement, it's a desired requirement. It's wish, by writing down the wish and citing its source, the stakeholder, what we're saying is we have analyzed properly, we have identified this wish, we acknowledge that you wish it, we have tried to capture information on how it would pay off, the justification or reason, and we'll look into it. But first thing we have to do is pass your wish through the architect, and the architect will determine if there's any known technology to get there and what that technology will cost. And if there's no known technology, we can't grant your wish. And if it costs too much and you're not willing to pay for it or wait for it, you're not going to get it because it's economically out of scope. So your wish will never become granted. Now, we have a name for the idea of granting, qualifying as a project target. We change the wish to a goal. Goal means there is technology and the economics are favorable and we can include it in the project, and you can expect us, if we're not crazy, to deliver the goal. Okay. So in other words, wish is business analysis again. It is not actually a committed requirement by the project. It is potentially going to be committed by the project, but then the name will change to the name goal. So now here is a simple example of the wish level. Here's a window for the wish level where we've chosen the level, we've chosen the date, and we've chosen some parameters specifically. So this is a very good definition of that wish, and it's exactly this wish, none other, that the architect has to determine, can we by this date, or within that time frame, grant this wish. Think of the wish of having what's it called, the shot, oh goodness me, blank mind, for the coronavirus. Okay, you all know what I mean. A vaccine, yeah. We all wish for it. In fact, we wish to get it next week, but everybody's very clear about the fact that nobody has one and nobody knows about it. So we can wish all we want, but until somebody's done the tests that were like somebody started some tests today, but when they've completed the test to a certain level, they might say, okay, with certain dangers, we can grant your wish to have this test, but it might kill off everybody who has cancer. So if you're willing to do that, because we don't have good enough tests for it, we've got a vaccine. Yeah. Okay. So for example, but if it said here that the targets were old people who had cancer, then we cannot grant that wish. Okay, but if it said only people who have slight breathing problems, maybe we could. Okay, so but here the window gives the detailed drafting of exactly what wish we're hoping to achieve by exactly that date. And we all know how important these dates are in finding vaccine for the coronavirus. If the architects looking for the vaccines, in this case, the top medical people, cannot grant this wish within that time, then it's too early to state a goal for, we can say, well, all experience with viruses to do, we'll have one within 2 years. We could maybe state this goal within 2 years, but we might say that that's still not absolutely sure until we really have tested the vaccine well enough to get in there. So right now we're unable to state the goal, but we're able to state the wish requirement. Okay, so we know where we're standing. Now here we're stating the goal for different combinations of parameters and different levels. Okay, in fact, the goal is symbolically going up from 35 to 40. At 50, we may have exceeded the wish level. That's nice if we're doing it. I'm not clapping my hands for you. There's a little black fly coming here. I'd love to kill off, the fruit fly or something like that. And at some point in time, maybe we're going up for the level 55. Here is some detail about the goal of 50, which is this one here. Here's some detail about the 55 goal for the year 2030. This is for the year 3 years earlier, 2027, and this is somewhat earlier, but we don't have the exact year there. But here's an example of 3 different goal statements. So we're in a sense drawing a curve in time, or if you like, long-term, medium-term, and short-term. Long-term, medium-term, and short-term commitments, which we think we can do. Now, stretch. Stretch was actually taught to us by one of our clients, Nokia, when they were in their heyday as mobile phone masters of the world. But the Finnish always liked to plan stretch goals. So when they started learning our method, they said, Tom, we're Finnish, where's your stretch goal? And we said, we don't have one, but we like the idea, so we'll plug it in. So that's how that got in there. Now, what stretch goals are intentionally saying at the unrealistic level, we may think about unrealistic wishes. At the realistic level, we may look at certain goals which are technologically and economically okay. But stretch goals, we don't know if they're realistic. We don't know if they're economic, but we know that we'd love to achieve them if we could, but we might not know for a while. But that doesn't mean we aren't going to say that we would love for these parameters, for evil people, to crack the problem of getting to 38%. So we're going to put it in the plan. So any smart cookie who's bored because they're sitting in their home office during Corona crisis might say, I'm going to look at those stretch goals and see if I can figure out an architecture for getting there and surprise the world with my coronavirus within 1 month. Okay, so in other words, it's not a formal plan to get there, but it's an acknowledgement that it'd be great if we could, and anybody who does know the answer is very welcome to figure it out and tell the rest of us about it. So it's a way of challenging the imagination, and it's a way of provoking innovation and creativity, and it's a lot better way than 7 hats and other less formal methods. Okay, I refer you to my book on creativity. You'll find it at gilb.com. which uses and points to these methods. Okay, so that's another target, stretch target. Part 7, meters. Now, meters, a meter is quite simply a test process at any level of detail. It typically, initially, we specify roughly what it is in about 10 words, and the test planners specify more detail. If you have time, this is a very fun test process. Here's a little stone hanging here in Norway, and here's the measurement process. If the stone is wet, it's raining. If it's white, it's snowing, and if the stone's gone, it's a tornado. And it's funny, but it's a very nice example of a test process which we found. There's a member of our family, John. Anyway, but so meters says how in fact are we going to determine, for example, for every sprint, how we're going to measure and get feedback of how far along we got, because we don't try to deliver code every sprint. We try to deliver numeric value enhancement in the direction of our constraints and our target goals. So here's a simple example. Here's the scale. Now, here is a meter, which are, again, these are the students in the BCS course, suggested that the recent hospital records from London Hospital for deaths, and we're getting this kind of thing every day for the coronavirus, aren't we? So that's a reasonable way of getting some idea of what's going on and whether the tactics we put in for, say, self-isolation of a certain class of people were working, the last 2 weeks. And but the scale remains the scale. Scale doesn't tell us anything about how we're going to measure. The meter makes a decision. And the thing about a meter is that it has to be practical. We can't have 5 years of studies every week. If we've got to get the feedback this week to impact next week's sprint, then we've got to have a quick and dirty meter, but it has to be a good enough quality meter that people will respect it and be able to use it in some useful way. And for this means that there can be several different classes of meters. For example, short-term quickie feedback meters and long-term health institute study meters might be appropriate for the long term. So you can have many different meters depending on your needs. A very advanced way of looking at meters is to recognize that different meters have different quality levels. I've listed some here, which is obvious on reflection. And we need to really decide what are the qualities we need to measure, say, corona virus on a monthly basis. And what costs are we willing in practice to spend every month to get data of this quality. So this is actually a multi-dimensional architectural problem where you have, if you like, a meter architect needs to design or architect a meter that meets these criteria, which could be numerically specified using a scale and a wish, within these cost constraints, especially time. And then they have to say, is there any meter which is good enough quality and good enough resources? So that usually we don't go that far. You would on the very largest of systems, but usually even with Corona-style planning, some of this is reasonably by the seat of your pants and obvious. Okay, but some classes of systems might require that we got formal in these value areas. These are the values of the testers, if you like, and these are the costs of the testers. So very advanced test planning. Part 8, we're going to look at some more background specification parameters. Now, the thing I didn't specifically tell you is that all the benchmarks we looked at and all those are, in fact, a class of things we call background specification. That is, they're not the real requirement. They're just there for the background of knowing how good our old system was, how good we expect our competitors to be in the future, that kind of thing. So they're background specification. Core, non-background or core specification are the real requirement with the scale and the goal and things like that. Those are the essential requirements. But in dealing with requirement specifications, I believe we need a great deal. Let's say 90% of the whole requirement specification needs background specifications like past, status, even wish, and these kinds of things as a background for making a decision about what should be our real requirements, our committed requirements, our goals. So the background specifications are many. In language, there are 20 to 30 background specification ideas specified in the competitive engineering book, for example. But if you take a look at why we bother to do it, why we bother to spend time and money in developing requirements when put in a whole lot of things that are not, in fact, the actual requirement, their background, you get a list like this. But it boils down to we use them in order to prioritize and understand priorities. We use them in order to understand risks and degrees of risks and risk we might work on. We use them in order to perform quality controls, like is the goal 100 times more than the record would indicate a quality problem of some kind. So, and some of these we actually use to do such prioritization, risk management, and quality control automatically because things are so well defined. In our tool, valplan.net, we already do some of these things. For example, the prioritization fully automatically using information from background specifications. So we're headed towards artificial intelligence in requirement specification. But to do that, we have to have clearly defined ideas and terms so it knows the difference between, say, a record and a wish. Here are some examples. Here are 4 different background specifications which have to do with people and their responsibility, authority, intended readership, specification, owner, responsibility for delivery of the values and implementation. All very important to know about for any one requirement, not for the whole project, for any one requirement. And but they are background information. But for example, if we had nobody responsible for the implementation, we might be able to say, well, wait a minute, is there anybody who has the time and ability to do it at all? And if not, do we have a problem, Houston? Okay. And further, here are stakeholders, very critical general form of background information about requirements. So we can analyze all the stakeholders and make sure we have all their critical values at all times, and that's continuous analysis. And then rationale, that's pretty much like the justification at the end of a user story, by the way. You know, why are we doing this? And then cost impact and value impact to date. This would be, we've already done some planning for strategies and architectures, and now we know something about the cost, something about the value is background information. Okay, so long story short, here also the status is background information. And even this ambition level looks like one of our requirements. It might even be what the CEO has said. But in fact, by the time we've defined a scale and a wish or goal, then this really looks more like background. That's what the big boss said. But the scale and the goal when it comes in is really the requirement that we're really going to do. And everything else there is just background. Here's a little bit more detail on the stakeholder, where we go into some detail about what their roles are and any other notes in the window for the stakeholders. And so if there's any change in this, for example, if one stakeholder demands or requests a change in a requirement, we have a list of other stakeholders that we might well confer with or inform about the change, like whether they agree to the change at all, and whether they, now that we're going to change something, have their own changes in mind since they were last interviewed 1 year ago or something like that. Okay, so but it's important to understand more about those stakeholders, like exactly who to contact, what is their email, what is their telephone number, how influential are they. And we've planned a lot of building into the tool, a lot of stuff about stakeholders that isn't into our advanced tool yet, but we do have our dreams about how advanced information we're going to have about stakeholders. Part 9. And not too bad. We're halfway through the talk, and we're halfway through the subject, so that's a good sign of something. Okay, so now there's a chapter in the book called Making Use of Value Specifications in Practice, and there are quite a lot of things, but I've just picked a couple of samples to give you some idea of what you might use the value specification for. So the first thing is contracting and proposals. Scroll. Good. So once you have decided to become clear about your requirements, for at least the reason that your team understands things, you have a side benefit of being extremely clear, because if you're going to send out things for bids and choose bidders and contract with them and reward or pay them as you go along, you need clarity for that purpose too. They're in fact part of the team, the external team if they're external people. And so a thing that immediately then is obvious is if you have quantified and clarified requirements, you can use them in any form of contracting and proposals. Doesn't that sound logical? And you can't use something like vastly enhanced security in a contract or proposal. But you know what? Some people do that directly or indirectly, maybe just by pointing to their bad requirements or their user stories or something like that. So we got to stop it. You can't seriously contract and seriously pay for highly ambiguous value requirements. That's ridiculous, childish, and we got to stop it or make it illegal or something like that. Now, another use, these are actually two different things. Let's start with this. I was working with IBM in Japan, and they're working on a project about artificial intelligence with a whole lot of universities like MIT, USC, Harvard, whatever. And they wrote a report on basic principles of artificial intelligence, which was sent to the Obama White House. And here is a page. They have a set of things they call principles of artificial intelligence. Now, if you start reading these principles, ensuring the ability to explain and verify blah, 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 and ensuring controllability and ensuring robustness and giving consideration, what have you got here? This is a perfect example of the very ambiguous set of requirement values, okay? And it turns out if you go into depth in the report or anywhere else, and I've checked with my Japanese IBM friends, there is no better definition, no scale of measure for any of these. Now, this is about artificial intelligence, which according to my friend Musk will destroy the world if we're not careful. And it's going to the President of the United States. Okay, and what is it? Well, some people call it bullshit. Okay, and I call it bullshit. And I'm really worried that some of the best universities in the world are operating at this level with something as critical as the security and safety and privacy of artificial intelligence systems, like the cars we're going to drive that are going to be self-driving. I can't believe that these people are, without complaint, operating at this level of silliness and without taking the time and trouble to quantify these things and clarify these things. By the way, if you want more detail, I've got some links because I have taken the time and trouble to find scales of measure and show that all of these can indeed be quantified. And the Japanese friends of mine at IBM said last year they were completely in agreement that this was bad and something has to be done about it. So I've got some friends there, but whether these other, and surely any advanced university would know in their soul that things like this have to be quantified, or they can't even do any research on it. So I don't know what's going on there. Now, another similar thing happened last summer. A Polish friend of mine, Pavel Nowak, was visiting my summer cabin, and I said, I've written 4 books this summer, one of which is the requirements, value requirements book, and I'm thinking of writing a 5th book. And he was very interested in United Nations sustainability goals, and he gave me some links, and I took one look at it, and guess what? The sustainability goals, like eliminate poverty, are the same bullshit level as these. We seem to have cultures tackling very large, worldwide, many decades problems, like the whole health and wealth of the whole world. It's called sustainability at United Nations level, and they are actually operating at the bullshit level. In other words, a series of nice sounding, highly motivating words, which are not in fact officially defined by the United Nations. There have been some attempts by others who recognize this is not good enough. And but what I did was I wrote a whole book on it, which is going to be, in fact, our 5th BCS course about 5 or 6 weeks from now. So I'll talk about it more then. But what I do is I demonstrate that these are highly ambiguous, in case you wondered, the UN sustainability goals, and you can quantify them. And I've got some agreement amongst the powers that be that you should, of course, quantify them because they're so damn important. So this is another use for this. These value requirements are things like artificial intelligence planning for the world, so it doesn't destroy the world and the robots don't take over, and the United Nations sustainability goals. And I'm sure there are lots and lots of other extremely large, important projects, some of which are pretty software oriented, like AI, and some of which are just simply systems that need to get better. So there's the link to our May 27th course on this. So welcome back, and I'll be reiterating the same things, but in the context of artificial intelligence goals like these and sustainability goals like United Nations. There's the idea of, once you've got structures and quantifications for clarifying value requirements, you can present them in different ways. So here are just a couple of the dozens and dozens of different ways of presenting to meetings and groups of people electronically and whatever. So here we have an ambition level, which is something maybe the boss or United Nations wrote. I've bolded some of the terms that, in fact, I've decided are highly ambiguous, like best security. And then I've pointed to a goal where I have, in fact, see, the best security is at 50% level, and customers and company are the organization, and all types of attacks take control of systems. So what I'm done is say, I can present what we started with, because that's what United Nations or the universities or the big boss started with. And I'm saying, here is exactly step by step how we're handling it. That is, we have not ignored as bullshit. We've decided that it's okay for a very high level to specify things like this. It's okay for United Nations to have very high level ideas, but it is not okay that this is the only level of specifying requirements, and there is massive ambiguity. If every one of these has 10 possible ambiguous interpretations, we have hundreds of combinations of interpretations, and we need to show that here is a very specific interpretation and discuss whether this is a valid and useful interpretation for these parameters by 2027. Okay, so this is one example. We present even the bullshit stuff, and show that we are tackling it systematically, and even get buy-in and feedback from the powers that be that this is valid, we accept this, drive on and do stuff like this. We're very happy that you are getting more specific and that this thing can be done by 2027, things like that, rather than the long-term goal of 2030 or something like that. Here's another way of presenting things. Now, here are our value requirement goals. Here's our tags. These are, in fact, from a BCS course. We're not showing you the scale of measure, but they're visible when you want them to be. But here we have the level, the reference level, the status, and here's how good we want to get. So these two numbers are the from and to levels of the value, very roughly. Now, here we're bringing in something we're going to talk about on the next course on 29th of April, and it refers to the value design book, which you can actually download and take a look at earlier if you want to. And here's what we're going to be talking about. See, these little bright ideas, modular construction, London living rent, and more deterrence, are not value requirements. They are the solutions, strategies, or architectures by which we hope to achieve getting to our requirement value goal levels. Okay, so the question is, when we plug in the Mayor of London's suggestion that we should have a London living rent, we need to be able to ask questions like, okay, but we can't just do it for its own sake because the mayor said. We have to do it because we have agreed with the mayor that these are the value goals and we have to achieve these. So the question is, what do we achieve of the housing type goal of moving towards 3 with London living rent? Well, there is an estimate, and how we do this is the subject of next week's course, but somebody has come up with an estimate. We get 50% of the way. In other words, we move from 1 to 2. We're not quite at 3, but we are 50% of the way getting there. That's the estimate of the impact we'll get if we implement London living rent as specified in the detailed specification, which is not here. This is just the tag. What's going to happen with the crime rate? Well, actually, not much. In fact, we're going to go a little bit backwards. What about type of tenancy into rent? Well, actually, we're going to get a hell of a lot more than we bargained for, but that's just good if it isn't too costly. What about average cost of a home? Nothing. What about housing features as defined as a value? Well, hell of a lot more than we bargained for. What about rental charges? Oops, minus 4%. What about the to buy goal? Oops, minus 60. What does all this mean? Well, it means something. It means overall, London living rent's going to do a hell of a lot of good there, 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 and there. And the other ones, well, maybe we can tolerate them, maybe we can't, to be seen. But we're going to learn how to understand how one strategy impacts multiple values simultaneously, and in fact, multiple costs simultaneously. So we can make decisions like, we recommend to the Mayor of London that he does London living rent next month, something like that. Anyway, but you cannot do any of this if you have not quantified your values. If you have these user story level values, you can just forget seriously looking into any of these or making any serious estimates or recommendations. So one thing you can do is present the architecture to any other architects. Do you have any better architecture? And any other stakeholders, like, these are the suggestions we have and this is how good they are. Will you give us a go ahead? Will you give us the funds? Part 11, just bring up the notion that up to now we've mainly looked at what looks like one level of value requirements. And if you're one stakeholder, you maybe are focusing on looking at one level. Like if you're the CEO or the project manager, you're possibly looking at 2 different levels here. And first I just want to, now it turns out that at the top level, you have some ends. Those are your value requirements. We also call them visions. And I can give you a little booklet called Vision Engineering for free. Didn't really put that there, but if you remind me or email me, I'll give you the vision engineering book. This is, visions are what top level people have, and the ends they have are their visions, okay? Now the strategies they're thinking of doing to reach their ends are their means. Now it turns out there's a level below the top management, say the government of the country, say civil service sector for energy, and it turns out the means that these guys need to do are in fact, which could be make sure you have a European energy network that works after Brexit, become the requirements, the objectives, the ends of the Ministry of Energy. And they will have some technical means, like even after Brexit, we have to have an agreement with the European energy suppliers. And onwards, this goes downwards to the lawyers who are going to make that agreement with the energy suppliers to deliver the energy after Brexit so that we, in fact, have full supply of energy in United Kingdom. So what you'll find is one, as we say, one man's bread is, no, one man's bread is another man's poison, something like that. And but one man's means become the next in the hierarchy's ends, and that one's means becomes the next end. So what I'm trying to say is that we can look at, view the big picture for very large, complex, high scale systems as a set of responsibilities. So this is a responsibility area. This is your boss, their boss's responsibility area. This is their boss's responsibility area. And in fact, to solve problems like what's good for the nation or what's good for the world, like above United Kingdom is maybe World Health Organization or United Nations, we have to be able to systematically look at ends and means. Now, to do that, we need tools like clarification and quantification of ends and means. And I've been talking about that all the way through, and we'll talk about that even more next week. Okay, so let's just say this whole slide is trying to say something about that. Now here's a more detailed slide of it. This book is from about 1992, Value Focused Thinking. There's the author who I've met once. His name is Ralph Keeney, and he's a very deep and interesting thinker about these. And he gave some names to these different levels. He said, at your level, call it strategic level, like you're the chief technology officer of a corporation. Now, you probably, if you're chief technology officer, you probably have a CEO, and that's your client. And you have to do what the CEO says. The CEO probably has a client called the board of directors or shareholders. But the CTO probably has some supporting means like a division developing products, which probably has another responsibility area to like a product development project. Okay, so now the beauty of this is everybody, no matter where they are, has their level of requirements, and then there's a level above them, and there may be several levels above them, and there are a level or levels below them, but he's put names on them. The means objectives are the levels below you. Strategic objectives are your levels, and fundamental levels are what you have to respect because they're your boss, so they hold power over you, such as European law or something like that. So now I'm going to show you what we did with this on a real client, Ericsson of Sweden. We did about 10 years of work with them in the 90s, and they had one project which was their productivity study, where they tried to improve the productivity of several thousands of engineers by as big a factor as they could, because they couldn't get more engineers. And I'm not going to go through all these slides, and certainly not in detail, but it's a whole case study. Here's the bottom line. We figured out we could improve productivity by a factor of 2 within a few years, and we would use these strategies. And we had some long-term and short-term ideas, and we wanted some decisions from Thomas, who was the chief technology officer, without going into detail there. Ericsson already had a policy which was very clear about their qualities and values, they took an engineering approach to it and said, of course, we will define all these things clearly and quantitatively. And we were in the process of teaching them some methods of doing what they wanted to do. Here you have some levels of objectives from, here's some levels of life, kind of quaint. But here's a reminder of Keeney's level of objectives. But we're going to look at is the following. At the Chief Technology Officer, his name was Thomas Erickson, turns out. Here were his objectives. We used some time to actually use 14-day study here, Kai and I, for the Chief Technology Officer. And these were the names of the objectives of the Chief Technology Officer. We quantified all of these. But there was a level below it called means objectives, which we also quantified. And there's a level below that, which were not objectives, they're strategies or architecture. And here's the list of what they were thinking about. These are the means by which we're going to achieve the means objectives. And we had some policies for prioritizing these strategies, and which was there realistic. We'll get into that next week. And here were, in language, the actual quantifications of the Chief Technology Officer objectives. And you should be able to read some of that given the earlier lecturing I've done, but these are the real ones we did. No special tool, just using Word to put them in there. And predictability of time to market is quite cute. How do you, here's the ambition level, blah, blah, blah. Here's a scale, and we're defining the terms. So we go along and deciding on how good we want to be. Okay. Product attributes, these are the quality attributes of their product, and we're generalizing, but we're quantifying all of those. And customer satisfaction, which is, they already were quantifying and measuring at the marketing level, and profitability. And here are the means objectives, in other words, the level below that, what quality or value objectives do we have to reach in order to reach the higher level objectives, complaints, but using the same language that we've been teaching. This is, it's a second level, feature production, same language, improvement, return on investment, same language. Okay, so that was just a very quick case study, but it's showing the use of these value requirements in a real example from a named client, which is still a successful business. One thing we've learned about our methods, to our dismay, is that our best clients are multinational engineering businesses, because they understand that what we're teaching is in fact an engineering discipline. And people who don't listen very well to us are people who are not engineers. They may call themselves software engineers, but they're not engineers, they're programmers, and they don't understand culturally that we have to move to an engineering and scientific level to handle really large projects like the automation of a self-driving car, artificial intelligence, or managing the National Health Service, or the coronavirus, or something like that. And those are the interesting problems. But engineering cultures understand that they have to approach these problems with more rigor. And I've sort of given up hope that my IT programmer friends will ever understand it, but other people will take over in order to succeed in their projects. And those people will be using an engineering method. Hope some of my programmer friends would like to step up and become real software engineers or systems engineers. Follow the rest of the course and lectures. Okay, yeah, now here's part 12. Sorry, somebody want to?
Yeah, we've got a question just before we move to the next part.
Yes.
In your slide about the best security, says Jerry, the statement states losses and disturbances which transfers to attract results equals all. I don't recall exactly what you meant. Best security.
I'm not sure which slide you're referring to.
Goes back.
Is it in the error?
I think if you had, your example said we want to achieve the best security.
earlier, right? Not in this example. Yes, in the security example, yes.
So,
and question is?
Losses and disturbances translates to attack results equals all. Is that
Yeah. Oh, let me tell you what all is. All means that if you had 5 different scale parameters, then it means all parameters apply at the same time. I didn't define that, but that's
is
just
this not still
how the language works.
He says, is this not still a high level of requirement, as it isn't clear of your specification what is really meant by the original term, losses and disturbances? I'll just
again
enable Jerry's phone so that he can explain that himself.
Yeah, that's a detail that comes up in reading a book or doing a 2 or 3 day course, but I admit I skipped over it because of the nature of this 3-hour presentation. So it will be explained, but there's a limit to what I could explain of the detail there. But that's all right. We can handle it as a question. All means all of the defined scale parameters, even future ones.
Okay.
There's no limitation or exception.
Thank you.
Okay, so moving right along, part 12. Now, I've alluded to the fact that when you're finding architecture, you have to find architecture that can be done within the deadline, within the budget, with the skilled health workers you in fact can recruit, to mention the current situation. So, so here are using essentially the same methods of definition, i.e. with a scale and status and things like that. We've taken, and this is from the BCS course work, we've taken some resource ideas, capital cost, calendar days, full-time equivalents, and maintenance costs, so 4 different resource ideas, and we have defined budgets for each one of them, okay? And then in looking at the different designs, this is that table we'll talk about much more next week. But here's design 1, design 2, design 3, design 4, design 5. And these are so this is the percentage of the capital cost budget, 14% we expect to use for design 1. So that's acceptable. You know, as long as if it used 99% of the budget, that might be a very bad idea because there's no more budget for these others, right? If we needed to use them too. Here, however, design 1 does use 100% of the time to deadline, the calendar days, 1,000 days budget. So that's not very good. We have to work in parallel to deliver these others, which also exceed, exceed the budget. Here, the full-time equivalence is only 5% of the 9% of the budget. Sorry, so that's okay. And it's not using any of the maintenance cost resources for some reason. That's more than okay. We're not going to get into technical debt there. So long story short, we use the same ideas of specification to specify not only the value requirements, but also to specify the resource requirements, that other type of requirement. And so we can simultaneously look at the values we deliver using that table I showed you earlier, which we'll discuss in more detail next week. And we simultaneously can look at any set of resources that are limited, and we have to be aware that we're not using more than we can allocate, or at least that we need to allocate more than we are planning to allocate, if that be the case, before we give a yes to the project. We can even add up the generically, roughly, how much of the resources, the 4 different kinds of resources, any one of the strategies is stealing, and we can, and as we'll show next week, we can look at these resources with regard to the plus-minus uncertainty and credibility of estimating resources. That's pretty advanced stuff, and that's what we're going to look at next week. But long story short, we can use the methods we're talking about to look at any set of multiple resources that are deemed important by this project. The second thing about resources, long-term and short-term, is that we can manage the resources by decomposition. What does that mean? Well, I've got 4 different decomposition methods, which I talk about in 60 pages of detail here. You can have a free copy of the value planning decomposition thing, which talks about it. But by decomposing our strategies or designs, we can decompose them so that, say, into 5 parts, but we can decompose them so that we have decomposed so that we can use, say, 1/5 of on one of the 5 parts of the capital cost or the time or the people. We can decompose so that we get different, a variation of different resources that will be needed, and we can choose things that don't use too much of the resource too early. Now that's a mouthful, and it's very generic and very high level, but at least I'm pointing out that systematic methods of decomposition, which are detailed here, can be used to manage the cost picture. Okay, and I'm afraid I can't say much more than that without spending another 3 hours or 60 pages. Here's another value. This is actually from a course where we're decomposing some of the values that the course participants came up with into these things here. And then we make use of it to maybe pick the one that gives the highest value and lowest cost and do it first. This, by the way, is our delivery cycle for language, where we start with the stakeholders. We then find out what are the stakeholder values. We then find the solutions, which is this lot here. We then decompose the big solutions that might take 3 years to things that can be done every month or something like that. Then we actually develop, this might mean reading code, and then we deliver the code and integrate it, which might be to an old system. And then we measure how effective and cost effective it was. And if we learned that it was either like we thought it would be, very successful, or not so successful, cost more than we estimated, delivered less value than estimated, we have to change things. And we continue this cycle until all critical stakeholders have received all critical values. Project stop. Okay, so that's a large scale. This was developed in Poland on a 2-day course similar to what we hold at British Computer Society, where we had 60 people divided into 23-person teams. This is one of the 3-person teams, I think. Okay. Deep breath, part 13. 45 more minutes to go, so no problem. So this is about, what about change control? In other words, stakeholders pop up. There are lots of them. They can be slow to react. They only react when provoked, like we're thinking of changing this value. How do you feel about it? So there's the requirement specifications need, as all requirement specifications need, change control. And so what kind of methods do we have for change control? Now, the big answer is there are order of magnitude 20 to 50 different things built in here that give us various forms of change control. And I'm just going to show you some simple example. So in the specification, here's one for user experience, there is an owner. Now, owner is short for specification owner. It means Eugene is anointed as owning this specification and, for the moment, no other specification. So they don't own all requirements. They don't own the project. But anybody who wishes to change anything in this specification has to go through Eugene. Eugene has a password which enables him to change the specification, and in principle, nobody else has the power to do that. Eugene knows all the corporate governance about what he has to do to make a change, like confer with other stakeholders, do a form of quality control, against the record, and all these kinds of things before actually publishing a change. So long story short, we decentralize the change control, giving decentralized power to a specification owner who's responsible for this and only this. Now, they may be responsible for 5 others out of 50, but we have to take a look at them. But in principle, they own this. And that ownership means they are focused on it. They feel that their honor is at stake, and they will use the governance procedures of corporate governance to do proper change. And that will ensure that proper change control is more likely to happen. Here's the detail where another detail, where we're taking the ambition level, which is usually a one-liner. Here it is: new users should be able to understand their system quickly. And we open up to a window which has more detail about the ambition level. And it turns out the source was, hey, Eugene, maybe the same one, maybe a different one, on that date. And this is just something I put in for the value requirements book. Okay, but now what it means is I'm going to change, if I'm going to change the ambition level, or I'm even going to reinterpret it by a different scale or a different goal, I should talk to Eugene, because Eugene is the source of this. And I can't just forget that he made this statement. Eugene might, by the way, be the CEO for all I know. Okay, and well, I need to corporate government should say that if any change is being made to any part, including ambition level, then the source of the part must be checked out and conferred with, and must give feedback, possibly permission for the change. Okay, so that there's this. You'll find that any window you open here has actually the possibility of saying who is the source. Actually, there are 2 sources here. This actually automatically logs exactly when I wrote this stuff, but I acknowledge I got my information from a person called Eugene. Okay, so here's the source of the actual change, and here's the actual information. Here's the source of the new user should be able to understand their system quickly. Here's some more information in the window, which says that I corrected a typo. But I could have corrected it in the wrong way. So that's interesting information. I can add any comments I want in a window for any statement in the specification for the requirements. Okay, but that gives us more information about how we can do change control. As I said, there are probably 30 to 40 details. Almost every line of specification arguably helps us with change control, because it's more clear, because it's digital, because it is well defined, and a few other reasons like that. So, part 14. Now, long story short, I already showed you how we use an impact estimation table to look at design and architecture, but I said a bit more about that in the book. But in fact, this is the whole subject of next week's 3-hour course, and it's the whole subject of the value design book. So I won't do much more about part 14 than remind you, I start talking about designs and architecture and how they relate to requirements by using this tool, the impact estimation table. And I do it in that book, which you can access right now, if you know how to access stuff. And certainly you'll find it in our 3-hour course next week at this time. Now, part 15. There are lots of different methods that either are requirements or are the only form of requirements some people use, for example, user stories, or at least contain some notion of requirements as part of what they do, like a larger architecture method. And I've already commented on user stories to a degree, because for many of you out there, that's a main form of requirements you're using. But what I've done, I've taken a number of methods, about 10 of them, and I've made some nasty comments. So I might hurt the feelings of some people who have bought into these religions. And you can now stop listening to this lecture if you don't want to feel offended at my nasty comments. Or you can listen to what I have to say and then email me nasty remarks back. I can take it. So I'm prepared to have a discussion or send you more information. But I'll make it very simple. Virtually all the methods that are not my methods, in other words, language with quantified requirements, suffer from the requirements problem that they're not quantified. And if you need to, if you get that idea and you're done with it, you can pick up on this later or don't have to listen to it. But now here's a longer checklist, and I'm not going to go through this in detail. I could, I almost have time, but I think it's a bit overwhelming. But I've got here about order of magnitude 18 different things that I look for in other methods. So you could use this as a checklist to analyze any of the methods I am talking about and any methods you like or you use, like your current methods. And it's sort of a checklist of, to what degree do you meet this standard for clear and powerful definition of requirements. And maybe you meet it to a certain degree, but maybe there probably are at least 10 things here you don't do or don't do well enough. Okay, now what I'm claiming is my method or language does all of these very well. Okay, and I don't find or know about any other method that comes near, but I would say that, wouldn't I? So if anybody actually does know about other methods that come damn near, would you please inform me, and I'll change my tone of voice or compliment your method in the next presentation. But I spent a lot of time out here worldwide where nobody has been suggesting there is anything that meets these criteria for requirements methods as well as what I'm presenting. And if it does meet all these criteria and better, you should use that method and not my method because it's better, right? Okay, so here's the first one, now user stories. Now I've already made some comments on it, but the user stories I see both by sampling real projects, I've done quite a lot of that, and by going to the internet and looking at all the examples I can find, and I'm on Mike Cohn's weekly free mailing list about user stories. He's my good friend and he is Mr. User Story. So I have as much, you may have a variation of user stories, which is I've never heard of, is very advanced, and I'd really like to talk to you about that. I'm trying to develop more advanced user stories, as I already hinted, and I will discuss that by email with anybody who says I'm working on very much more advanced user stories. But the run-of-the-mill user story looks like this. It's short. It's about 10 words. It contains these the notion of a user, the notion of what you want, and the notion of why. And that's all we find. So I said that's okay if that's the beginning of a discussion about what your requirement should be. And maybe that was the original intention, but that's not how it works out. There is, for too many people, there is no other form of requirement. We go straight to the coder. Okay, and what I'm saying is that's not good enough because the coder and the tester could easily misunderstand most all of this, do the wrong thing, and this might be ultimately pointed out by an unhappy stakeholder 2 years after delivery of the system, where that stakeholder is the European Union and said, in spite of Brexit, in order to export to us, you have to follow these rules for privacy, and you're not doing it. You're just doing what somebody called better privacy in the user story, and that won't cut it. Okay, so long story short, if user story were instead of the ambition level, and then you did all the other stuff, I'm quite happy with user stories, okay? But if user story is the end of the line and is in fact highly ambiguous, and can in fact be misunderstood, I don't think any responsible person should use that or do that the way most of us seem to be doing now. Okay. Now, use cases. Here, an example of use case stuff, nothing harmful. What I did for fun was I said that use case could be a very interesting parameter in the scale. So I worked up a little example of using a use case in the scale. And any one of these can be defined more fully in language. I haven't done it right here, but I can take monitor requests and define it as in the detail I want to in this system here. But so I'm saying I don't have a problem with it as a potential parameter, so that we know which use cases to refer to in a scale. I do think that using it as anything resembling a requirement is not on. And maybe somebody said we never expected to, and we're all happy there. But I still think this is an interesting way of looking at it as a parameter in a scale of measure. Now, there's something which most of you have probably no particular relation to. It's called earned value management. Internationally, it's largely a US government method, which is still very much in force. And it's a desperate attempt by the US government to try to get value for money instead of just spending money and getting no value. And it is actually a notorious many-year failure. It gets misused all the time, where earned value gets persistently misunderstood and misused as money spent equals earned value, which is crazy, but there it is. So long story short, earned value management needs something better. And unless you're doing a US government project or a government project which uses this standard, you don't have this problem. You don't have to worry about it. But it certainly is not an advanced method for delivering planned value like they try to talk about here. It's if you go to the details, it's difficult to find examples of people really doing this, but I expect there are some out there. People like Paul Solomon, my friend, fighting for actually measuring the fact that the government should pay for the value delivered. But most suppliers are very happy to claim that if they spent £1 million, that's the value delivered. Please pay me £1 million. Okay, and unfortunately, that's a corruption. Now, functional requirements. Okay, now in simple terms, what a lot of people call the requirements traditionally are very largely functions. That is a description of what the system must do. And that's this area here. And then we've begun to recognize that there's something which many immature people call non-functional requirements, and that includes all the value requirements and all other types of requirements. So long story short, functional requirements alone, even if you just call them requirements, are not good enough. They're too narrow. They don't really describe the essential reasons for building a system. In fact, you'll find the old system probably has all the function you're going to need in the new system. And what you need in the new system is better value requirements using better designs. And that's what I've been talking about this week, and we'll be talking about next week. So long story short, function requirements, even if you don't recognize they are merely functions, are not the way to go to do the main thing that all projects are really asking for, which is deliver enhanced values in the future. Some of you may have messed with balanced scorecards, which come out of Harvard Business School, Nolan and Norton. And I've done some work with even some extremely large government clients with balanced scorecards. Now, I'll make a long story short. The problem with balanced scorecards was that they discovered that managers were over managing the financials and just giving lip service and bullshit to the non-financials. So they said, we've got to balance our scorecard, in other words, our scorecard for managing the corporation, by looking at the non-financial requirements more seriously. Now, it turns out if you take a look at all the examples on the internet of how to do this, you'll find that the financials, as usual, are quantified, and most of the non-financials are not quantified. They've got the bullshit level, the ambition level, the user story level of 10 nice sounding words, and that is permitted. In other words, Harvard didn't advise that if you really want to balance things, you can't have all the financials quantified and almost all the non-financials not quantified, because the quantified stuff will win, because people will focus their attention on that which gets measured, gets managed, and you all know that. Okay, so long story short, now there are some versions of balanced scorecard which I've used. I found a British insurance company, and I can share the details with people who want it, who've done it very well. And this thing off of the internet at least is trying, not very well, but trying to give quantified attention to the non-financials. So there's a little bit of it, but most everybody who uses balanced scorecard that I've seen is stuck in the mode of the original balanced scorecard presentations, which they learn at a business school, which are never taught properly, and are very poor at these value. These are value requirements. These are also value requirements, but we all know how to quantify them. So long story short, poor practice is the problem here, and that's 99% of everything, I'm afraid. For engineering and engineers, there's something that Toyota developed that was pulled into the US by some friends of mine called quality function deployment. And the argument was, as with so many things today, Toyota used it, Toyota makes good cars, therefore it must be a good method for thinking about systems. Now, if you look at this standard example, you'll find some customer requirements, and if you look at them, they are value requirements. But if you take a look at them, they're kind of funny. Here's a number, here's a number, here's a number, but here is no number, and no number. What does it mean? It means that these value requirements were not quantified. Okay, so this is, and there is no other place where they're quantified, and these are just a reference to that. So this whole quality function deployment system starts off by not quantifying the values, which is what my whole talk today was all about. But it goes on then to do a kind of impact estimation table thing. In other words, here are the designs, and here is a subjective opinion about how strongly the designs, it doesn't say 15% or 50%, it just says moderate relationship. And it doesn't say who decided it's a moderate relationship, and it doesn't say how moderate the relationship was. It is a pure subjective, unaccounted for opinion. And this goes on and on and on. I've written a whole paper about it, which is available down here, where there are about 10 different things that this method does, which are very bad, but it looks good. It looks systematic. It looks like they're quantifying stuff. It looks like they've got an interesting priority system. And it is, in fact, structured bullshit. Now, quite recently, a friend of mine, Łukasz Stotek in Holland, pulled out something quite amazing. The Mr. Ono, who had done quality function deployment at Toyota and had spread the method to the US, openly admitted that he tried to fool the Americans as to what he was really doing with lean development. That includes this stuff. He tried to hide what he was really doing and just threw a lot of stuff in their face. And they went back and said, that's lean, Toyota does it, and let's teach it. Isn't that amazing? I've got the details of that if anybody wants it. In other words, for all I know, I always used to joke that this was disinformation by the enemy, Japan, to fool the West into using the method so they would develop bad systems. And it turned out I was more right than I could possibly believe I was. So in other words, methods like this idea that Google uses or Intel uses, say, design sprints, Google is successful, therefore you should use design sprints, is all over the place, and it's ridiculous. At Google, every member of the corporation goes to toilet approximately once a day. So if you want to build successful systems, be sure your employees go to toilet once a day like Google employees do. I mean, that's ridiculous, but people are out there saying these things about methods like design sprints and quality function deployment. This particular thing was being taught by American university professors at a Norwegian university for systems engineering master's degree. And I got so angry at them, I wrote this paper to defend the poor students against the narrow-minded, uncritical professors. Some of you may deal with things at the software architecture level. So I've got a couple of methods there. Now, here's TOGAF, which you can, like Scrum, you can get a license to kill here. And I'm a TOGAF certified practitioner or whatever teacher. And I'll say one thing for TOGAF. They very explicitly say that requirements should be quantified. And then I am unable to find any examples of quantified requirements. Maybe some of you can supply me with them. Surely somebody's followed that instruction in spite of the fact I can't find it published on the internet. But here, digital customer management capability is the requirement. And here's the description, more words. Here's another requirement, data-driven insurance capability. Here are more words, no numbers, no scales, no quantification, no structure, words, words, words. Yet in this very example right above it, it says the standard is quantified. I don't know. Is this quantified? I can't see any numbers there. Priority high, this is as bad as the quality function deployment with high, low, medium. So I have no respect whatsoever for TOGAF or anything in it. It doesn't walk the talk, but I'm glad at least it talks about quantified requirements. Then we have the Zachman framework, which is, I love it. It's got so much neat stuff in it. But even if you look at some of the underlying things, it's all boxes and balls without quantification. You don't see any numeric tables or graphs there. And I talked with Zachman for a whole evening about this. And I said, isn't it better to quantify? And he said, yes, but. And I said, why don't you change the whole of the Zachman framework to do my methods instead? And he said, nope, I spent my whole life and fought legal battles for the rights to my method, and people buy it. I'm not going to touch it. In other words, Zachman said, I am not going to improve my method to be quantified in engineering, so you can forget that. However, you might like to use the framework and plug in some of my methods. You have my permission to do it for free. I used to have arguments with people who invented UML. They came out of Ericsson of Sweden, Unified Modeling Language, and a lot of people use that for their requirements, UML. And I'll make a long story short. It is extremely obvious that dealing with qualities, values, and costs is not part of what can be done in UML the way it is taught and used. So forget it or add to it. Is that enough? And if anybody has taken UML and added the kind of stuff I've been talking about, my language or something else, that's wonderful. Please tell me about it. I've never heard about it. And I've talked with a lot of people who know UML and even invented it very well about exactly these things. And nobody's saying, but Tom, it has been changed since we originally developed it, and we can do values, and we can do costs, and we can do qualities. It's just not there. Then we have this new thing called design sprints. And I can't believe that so many people are buying into it, on the basis of, well, Google did it or Intel did it. I read the whole book on it written by Jake, and I found one case study which was not very convincing from a business which has now gone bankrupt. And otherwise, it just is not quantified. It's not systematic. And I can't believe people are selling it, but maybe it proves that if it's really, really so simple that it contains nothing, like a Scrum framework, maybe you can sell it to masses of people. And that, I think, is exactly what's going on. If you'd like to know about a similar thing, which uses 1 week to start up step by step, but uses my methods, here is a paper on the subject, and all of my books talk about it. In other words, I believe that the first day should you understand, but it should quantify the top 10 value requirements. Day 2 should identify the top 10 architecture or strategy. Day 3 should model how good the strategies are for the requirements on an impact estimation table, like I showed you earlier, all quantified. Day 4 should extract a simple subset that can be delivered next week in practice to measurably improve the value for a real system. And day 5 should be used to talk with the boss about actually doing this. Now, we've been practicing this for decades, even on very, very large systems such as the US Department of Defense systems. And it works very well, but here's the detail. And this is for babies in kindergarten, or I don't know, maybe it gives more structure to people who have no structure whatsoever to think about designing things, but it's not for serious systems of any size or scale, such as coronavirus, in fact, if I wanted to sabotage large projects, I'd say use this method of thinking, ha ha ha, your project will sabotage itself. You've got to be joking. So there is a little bit more detail, even some examples of real results from real corporations, where we do the 1 week startup, and then we go into what could be called a Scrum, using a Scrum framework, but delivering value every week like this. But it's based on quantified values, not unquantified, wishy-washy, yellow, sticky Mickey. Okay, I'm just taking the Mickey out of it. So that's that. Now here we have another one where people say, oh, Google uses it, Intel was using it, they are successful, therefore OKR must be great. Now I have to say one thing about OKR. It is similar, a cousin, a distant great-great-great-great-grandfather of my methods, because it does believe in multi-dimensional quantification of ideas. Good. But if you take a look at what it really does and really teaches, and then compare it against what I have been teaching, I think we can conclude that it is maybe okay for smaller activities like my personal method, my personal job. But it's not good enough for managing a large project such as coronavirus fighting in the UK or Brexit or something like that. It doesn't go deep enough. It isn't detailed enough. And if you want to extend it, you would extend it in the direction I've been showing you. So, but using it for everybody in a large corporation as a replacement instead of the things I've been showing you is a way of sabotaging what you've done, and any manager who makes that choice should ultimately lose their job, because what they're doing will tend to fail, and they will be found out and replaced by managers who do more serious stuff. But there are lots of managers making this decision, just as they've made decisions to use Scrum and other oversimplified things for projects that need more powerful engineering methods. A very popular prioritization method is the Moscow method. People keep on bringing that up. Now, long story short, I think it's, again, like many things, good, better than nothing for prioritization. But for serious things like COVID, like Brexit, like National Health Service, it is oversimplified to the point where it is dangerous and destructive. And here is a free chapter of my value planning book, 60 pages on prioritization, and which explain it. And that earlier thing about quality function deployment also explains it. So long story short, nice for primitive children on simple projects. And if you're doing something which needs to scale up, which is serious, which is about lives lost and won, like National Health Service and COVID, please use something more sophisticated, like the quantified engineering dynamic methods I'm talking about here. Some of you may have heard of capability maturity model, some not. It's much more widely known in the US and India, where absolutely all Indian corporations have made sure they've gotten a certification at some level, high level of capability maturity model to gain credibility in the Western world. And all defense suppliers in US and outside of the US need to get certification. But some people decided they simply wanted to use this method as a way of driving, becoming more mature in software. So there are still several of my friends floating around Europe selling the service of training people in capability maturity model. Now, I can't be totally against it because the original model, level 4, was actually based on my own ideas, and they were about software metrics and quantifying stuff. But what's happened over the years is a pretty good idea developed at IBM by these two guys for analyzing their own organizations, got taken over by a government bureaucracy and got corrupted, as government bureaucracies do, horribly much process bureaucracy, losing sight of all the original ideas. So even if there is something about quantification, people might skip over it and get away with it. So long story short, the idea was good, but it's been corrupted. We've got lots of studies about CMM and its cost effectiveness, and to make a long story short, they're not cost effective because the costs are horrendous compared to any effect you might have. So I'll take some honor for the original idea that mature software engineering does manage quantitatively, and here's the proof I've done that, but I can't take responsibility for the many-year corruption and malpractice of a stupid bureaucracy. So advice, don't waste your time. So 12 minutes to go, part 16. Formal standards for value specifications. Now, long story short, the competitive engineering book is effectively the standards for what I'm talking about. Here's a free copy of it. Here's a one-page summary of the standards, which I put in one of my newer books, Value Planning. And here's an example of some of the ideas of standards, which are well defined, like what is a rule, what is a policy, what is a process, what is a standard, what is a template. And there are detailed examples of these throughout the book. So long story short, I have published and made free the standards for language, and anybody can use them and abuse them and improve upon them in any way they like. But it's not kind of a rough sketch like many of those methods I've talked about. These are very detailed, very practical, and they are tested rigorously by corporations like Intel, Hewlett-Packard, and Boeing for decades. So as it says on the cover of the book by Intel, this stuff works. So above all, incredibly practical compared to some of the open-ended frameworks that are a little bit too open-ended. Or put another way, you can plug this stuff into the open-ended frameworks like TOGAF and Scrum and CMM, and you might end up with a sharp method that works very well. At part 17, I've been showing examples with a tool we have recently used, built by Richard Smith in Britain, and but deriving exactly how to do it initially from the standards in competitive engineering, and egged on by Kai and myself. And before that, Sun Kai spent 10, 20 years building a tool in spreadsheets, and we lived with that. But there's a limit to what you can do in spreadsheets to automate these methods. And so this tool is one that does all the neat stuff we wanted to do in a very tailored way. So again, you can do everything I've talked about, as we always have, using Word or a spreadsheet. And if anybody wants to make competitive tools, they're very welcome to do so. But take a look before you decide what to beat. Take a look at the tool, and then tell us you know how to make a better one with far more artificial intelligence built into it. Okay. So in the long term, I think there will be a variety of tools which automate the value requirement and value design. Part 18 about stakeholders. Now, here's the value cycle, as Kai and I call it, from guild.com. And it starts off with saying, who are our stakeholders? Here's a very structured version of those stakeholders. This is like a template or generic template. If you say, what kinds of, give me a list or checklist of various kinds of stakeholders I might have. Here are some attributes of stakeholders. I've written some papers and slides on it, which I haven't given a link to, but if somebody says, I want your stakeholder stuff, you can either Google it or ask me for it. But here are some quality attributes, or if you like, value attributes of stakeholders, which all can be quantified. It's a way of looking at what I know about that stakeholder. Here are some costs regarding the use of stakeholders. Again, another, so notice we're using this whole value management way of looking at stakeholders. And here are some strategies which will help us improve our use of stakeholders and improve their values. So this is a gigantic subject on itself, which can use value management of stakeholders. It's a territory I feel like I'd like to spend more time on, like maybe my next books. This summer, I write the book on stakeholder, and here's the outline. And if anybody out there says, I'm interested and I'd like to partner with you or have something to contribute, please do write me. I'll share what I have, and you can share what you have or come up with better ideas. And that was that. And there's 7 minutes left. I'll leave the last slide on this and invite questions until 9 o'clock your time. And then you want to do any more, there's how to talk to me. And welcome back to the next courses for 3 hours, 2-hour courses for the last 3 ones, by the way. Imo?
That was tremendous. I've now given everybody access to unmute their microphones if they wish to ask a question. Now, the first thing that comes up to my mind, I was very fortunate a couple of weeks ago that Kai took the time to actually show me how to run the Valplan tool and what you can do with it.
Yeah.
I understand that anyone can sign up for a 14-day free trial, but is there is there some sort of study guide that allows you to take you through the various features of the tool and how to use them?
Yeah. So built into the tool are masses and masses of videos and other helps. Okay. So there's both Kai and Richard have built enormous amount of help into the tool. Now, in the background, the competitive engineering book of 500 pages details everything in definitions. Much of that book is built into the tool, but not all of it. And then coming on our BCS courses with workshops, we use the tool, and we use 2 to 4 days, and we learn by doing it. But we're actually learning the language method, and we just happen to be using the tool. But people pick up using the tool by doing it. And finally, there's an option to get help directly as a potential user of the tool on how to use it. I guess that's it. There's no handbook for the tool except the built-in tools or the competitive engineering book.
Okay. And are there, the sort of exercises that you'd get groups of people doing in the workshop using the tool?
That's right.
Are those available somewhere that people can read?
Well, okay. Now, normally not. Like these are like 2 days in length. And so nobody has ever videoed them. They're not available that way. Now, recently, during Corona's times, Kai Gilb, look him up at LinkedIn, Kai Gilb, has been spending, like right now, he's in the middle of doing several hours a day with a consultant in Austria building a military system for free. Anybody can tune in and chat, showing the development process for a military system. So check out Kai Gilb's free coronavirus consultancy advice, and that they just happen to be used. This is really not a, this is not a tutorial on how to use ValPlan. It's a tutorial on how to plan value management that happens to use the ValPlan method is the best one we have for working with. But you can, and by the way, the previous videos of what he's done are there, available now, the past videos on Kai Gilb's LinkedIn website.
Terrific, thank you. We have a question from Gavin.
Yes, Gavin.
Can you hear me?
I can hear you. Yeah, yeah. If I maybe holding my ear like that says I can't hear very well, but I can hear you.
Great. So on ValPlan, I've just actually put this in text as well. So I just had a look on valplan.net, and it says register a new organization account. So is it intended for individuals, or does your organization have to register first?
Individuals can register as their own one-man organization. So organization means any entity which wishes to keep their things private and ultimately wishes to pay for or get free use of the service. So one person organization is fine. But what happens there is you get a private site that other users can't get to, and you can manage who can see your plans. There is a, when you get there, there's a public site we use for all the BCS courses. It's called guild.com. And you can actually, once you get permission to get in there at all, and it's a public site, an open site, and anybody can go and look at all the BCS examples we've done.
Okay, thank you. And thank you for your talk as well.
You wouldn't want your private plans on that site for obvious reasons. Thank you, Gavin.
Tom, you have a question on the questions tab from Jerry.
Yep. Which I can't see. I can just see my own slide, but all right, let's see what happens. Questions tab.
That'll be
I see my face
in the GoToMeeting application.
Yeah. Which button do I push? Make another attendee.
There should be a GoToMeeting. Oh, sorry, I can't see all of your screens.
Yeah. Now I can see it. I've got stuff. Yeah. Okay. I've got the right. Okay. I can now see the chat.
It's not in the chat. It's in the questions tab.
It's in the question tabs. Gosh, I have no idea. I've got the questions tab. Thank you. We're learning. And I can't see. I've opened it, but I can't see anything.
The question from Jerry was, what procedure is there for taking your set of requirements from your tool or from other documents to producing the software in any language, and hence developing actual systems for human use? I think your requirement method is comprehensive, but how is it actually used in real-world system development?
Right. Okay. Now, so you notice that cycle we had, that it ultimately had something called develop, deliver, measure. Okay. So those things are all in the competitive engineering book _1, with in fact a great many practical real case studies. That's _1. Let's just say these case studies are often snippets, but they're real and they've got detail. Most all of my other writings, whether they be slides or papers or books, contain real examples of delivery with real corporations or references to them. For example, the value planning book, which you'll find via our website, guild.com, is 700 pages. And being a large book, it has a great many detailed examples and references to real organizations doing real work and what they've really done. Number one, these methods have been used for decades, certainly since the 70s, 80s, and 90s and onwards in real corporations of very large, well-known ones. Intel, Hewlett Packard, Ericsson, Boeing, IBM, etc. And some of them, for example, Intel and Hewlett Packard have published on their own, and IBM on their own websites, a great deal of the results and measurements of the use of our methods. Intel's the best single publisher, a guy called Terzakis, and I refer to him in most of my books and other things, where they publish the implementation of the methods on real products, and they publish things like degrees of quality improvement and degrees of productivity. So long story short, if you scan my books and presentations, including this one, and go to the links, you'll find masses of information about actual implementation. But since this is a presentation about requirements, I have not gone into detail about the implementation. But as we move towards down the series, we're going to talk more and more about it. But we haven't actually planned a book and a course on the implementation bit. Okay, but it's just we've done it, and we've got masses of. See, Kai and I, we don't do it personally because we're consultants and teachers. So all the implementation at the client end, but there are detailed reports, and we have detailed case studies from almost 100 of them. Some of them British.
Thank you.
So are we done?
I'm just sending out an updated version to the slides.
Okay, good.
That was a
so
question.
we're
That was a
done
question.
with lecturing, done with questions. The updated version of the slides.
Yeah.
And you're very welcome to share those slides, those references with anybody in your company, organization, or professional friends, and tell them about, I don't know how long it's going to be until we get a video version of this available. Do you have any information on that, Imo? Like 1 day, 2 days? It took 16 days last time.
Several hours for GoToMeeting to convert the video to a format that we can upload, and then
right.
the BCS has to put it into a WeTransfer slot so I can get it
so
done.
we hope in a few days.
2 or 3 days. By the weekend.
And spread the word by Twitter and LinkedIn and your friends that they can catch up on this one and they can go forward on the other ones. The whole coming week, I'm going to make my slides from the book called Value Design.
Mm-hmm.
So we've got a couple more questions, but basically just expressions of thanks for your time and for the organization by the BCS. Yeah.
Well, thanks for putting up with me. Thanks. Thanks for listening for 3 hours if you did, or promising to do it.
Yeah.
Thanks for reading the book if you do. Thanks for any feedback or enlightenment. I don't know everything, and if you know something better, I'd love to know it. Just email me. And anybody who wants to get started, well, I think you've got enough to start here.
Yeah.
But like with anything, like playing a violin or playing chess, practice, practice, practice makes master. We have done our 10,000 hours. And if you want to master it, you're going to have to start doing your 10,000 hours. We've given you the ideas in writing, the free permission to use it, the tools to use it. If you want to get order of magnitude better than anything that's ever been done before, this is, we hope, an opportunity to do it.
Thank you, Tom, and we'll see you in a week's time.
Yep. See you next week.
Thank you, Tom.
Thanks very much.
Thank you, Tom.
Bye,
Tom, it's Margaret here, just to say thank you very much again on behalf of the Quality SG. So thanks.
Thank
All
you,
the best.
Margaret, for all your sponsorship for your group for all these years. We've trained a lot of BTS people.
All the best. Thank you a lot. That was
Bye-bye.
great. Bye.
Good health, everybody.
Cheers.
So I'll end the meeting at this point and the recording.